Hello, hello, and welcome. Hello, everyone. Thank you for joining us today. We'll be getting started in just a couple of moments. I'm your host today, Miriam Oglesby, and along with me is Liam Hampton.
Hello, everybody. Nice to see you. Nice to meet you. It's so great to see so many people here today. We've got a fantastic lineup again today, so I'm going to be helping Miriam with some hosting both today and tomorrow. So look forward to answering some questions and hearing what you have to say.
Yes, so we're both working in the IBM Developer Advocacy team in Europe, and welcome to our Developer Festival. We're so glad you're joining us. I see a lot of people joining right now. Welcome and happy Tuesday. It's great to see so many of you. And while you're joining and getting comfortable, I'll just give you a little bit of background and some housekeeping. So bear with me. On this channel, IBM Developer Europe, we have lots of talks and hands-on workshops like these from experts at IBM and from beyond. If you would like to be notified about our future events, you can follow us. I'll show you around Crowdcast in just a moment. So yesterday we had the kickoff of our festival. We had a talk on quantum infrastructure, machine learning, and deploying a chatbot to WhatsApp. That was a fantastic day. For today, if you're new to Crowdcast, your view should look a little bit like this. You can see more information about the event in the top left, and in the top right you can hit the follow button to follow our channel to know all about our talks and workshops. If you want to communicate with us in the chat like you are doing, then there's a little bottom button and text field at the bottom right. So I see people joining from Germany, the UK, Australia, wow, across the world. Great to see you. We also have questions and polls, which we will be using throughout the event. So you can interact with us, chat with us in the chat, ask questions to the speakers about their sessions in Ask a Question. And on the green button, you can sign in or sign up to your IBM Cloud account to follow along with the labs. So that's a little bit of housekeeping about Crowdcast. Today, our focus is on open source and artificial intelligence. And we've got our first speakers in the live stream already. And yeah, Liam, would you like to introduce the first session?
Yes, sure thing. So we have got Grace Jansen and Jamie Coleman, and they're going to be talking about open source in the world of Java. So come to the screen, everybody.
Hey, can you hear me and see me? Perfect.
Yes, we can.
Jamie.
Hello, everybody.
Hi, welcome.
Hello.
Thanks for having us.
Slow creep in with the video.
Yeah.
Right, so
Perfect.
We'll turn our cameras and microphones off and let you guys take it away.
Thanks so much.
Brilliant, thank you. Let me just share my screen and then we can begin this session. Okay. Grace, can you see my screen all right?
Yes, I can, yeah.
Lovely. All right. Let me just switch this round and we can get going.
Yep.
So good morning, everybody, or good afternoon. I know most of you are probably on mainland Europe, so you're an hour ahead, so it's your lunchtime. So thank you for attending our talk. Feel free to eat your food while we talk and demo today. My name's Jamie Coleman. I'm a software developer and advocate for IBM. And with me, I have Grace Jansen.
Yep, so my name is Grace Jansen. I'm also a developer advocate from IBM in the UK. And yeah, both Jamie and I sort of primarily work with Java, JVM technologies, but also cloud native technologies as well. So today we're going to be taking a look at open source in the world of Java.
Awesome, thank you, Grace. All right, let's get started. So this talk is a lot about different open source technologies and kind of where they've come from and where they've got to. So this is kind of a standard developer journey. So you imagine this is kind of your timeline. First of all, you need to kind of make decisions about what kind of architectural type you're going to use. And there's lots of different open source Java frameworks that can do this and lots of different IDEs that can help you along this journey. Then, of course, you've got to figure out where you're going to run your application server. It's usually done with a web application server or a web runtime. Then we look at tools and different things, so build automation tools, stuff like Maven and Gradle. And again, there is loads of different open source technologies in this area, things like test containers, all the goodness like that. And then we kind of move on to automating things and then actually deploying our applications. And this is really the kind of a journey that a developer has to go through. Now, some of these decisions may have been made for you, but as a developer, we really do nowadays have the power to kind of pick what technologies we're using throughout our journey. So here's a little kind of brief history of open source. There's quite a lot of different information here. I've kind of put some of what I think are some of the most important things in a timeline. So first of all, 1953, you had the A2 system, and this was kind of what I found as the first kind of example of open source, which essentially was a company. They were essentially shipping a product to their customer, and they were asking for feedback. A bit more primitive. This was all done on paper and put in an envelope and sent via the post to the company that created the software. But this is really kind of one of the first instances I could see of kind of the open source technology, or at least it being used by people. Then, of course, different things came out. So the Advanced Research Project Network, which eventually was succeeded by the internet, was kind of a place where everyone could provide feedback. And then you moved on to stuff like essentially the launch of the GUN project, which really aimed to kind of create an open source free operating system. So then Linux in 1991, it was the first freely modifiable kernel as an open source thing, which was amazing. And then 1993, Debian and Debian came around. And this was really when the first open source operating system was born. Now we move on a little bit to 2006 when Java was open source. So this really paved the way to have kind of lots of different JVMs and lots of different vendors to make it a bit more, I don't know, more open source, more free, more collaborative. And then, of course, Git was created. And I think one of the biggest contributions, or one of the things that has really driven open source in recent history, was GitHub. So having this kind of place where developers could all come together, they could share their code, they could write comments, feedback, create pull requests, and just essentially a standard place where open source projects could live. I think this really, really dramatically increased the pace of how many open source projects were available. And of course, I can't not mention the most successful open source project of all time, which was Android. I think over 85% of all mobile phones in the world are using this open source technology as their operating system. And this was created by a company which was now owned by Google. But again, it's a freely open source software. Doesn't matter your hardware, you can run it wherever you want. So these are kind of some of the big things in open source history which I think made an impact. Now, the benefits of open source, most of you probably know, but generally you've got your main four freedoms. So be able to study, copy, modify, and redistribute. When it comes to privacy and security, open source is great because you can have a massive community out there. And when you've got lots of different eyes looking at code, you will generally have people with different perspectives that might find bugs. So hopefully the aim is when you've got lots of different people from all different backgrounds in all different parts of the world looking at code, you can find hopefully security bugs it quicker. Generally, there's low or no costs. So open source software, if you're looking at the main freedoms, it's free to use. But generally, you get to a certain point where your organization is grown, and you don't really want to have to fix the actual bugs in the open source software itself. So that's when you start looking for licensing and support from other companies. And of course, having so many people working on a project allows for better quality, better collaboration, and better efficiency. So, for example, rather than just having one organization and their view of the world and how they think a project should be, you now have lots of organizations and lots of individuals all having their input into this. And of course, with efficiency, now I could, for example, I could have a problem with an open source project. I could raise an issue or a pull request when I go to sleep, and I could wake up in the morning and someone could have already commented on that, could have merged that code in. So having a big community and spread out around the globe essentially allows for a much more efficient project, I'd say. And again, it becomes a bit more agile and efficient because we are working in different time zones. So rather than doing releases every, say, 6 months or a year, open source projects generally get released quite quickly. So someone will make a change that will go into kind of a beta, and then as soon as there's enough kind of changes in that beta, then that could be made into a normal release. So it allows kind of open source projects allow these things to be a lot more efficient and agile. Okay, so Grace is going to introduce you to some of the open source stack today. And again, this is a fully open source stack. So everything on here is free. And we just kind of want to show you how easy it is to create enterprise grade applications with microservices or monoliths using free technology. If you went back 10, 15, 20 years ago, that would be nigh impossible. Whereas now you can basically get all this technology and you can try it out, see if it works for you, and build completely free open source solutions with it. So with that, I will hand it over to Grace.
Thanks so much. So the first one on our list that we're going to take a deep dive into is Eclipse MicroProfile. So to give you a bit of background information on this project, in case you've not come across it before, Eclipse MicroProfile is, as you can guess, an Eclipse project. So it's held within that sort of open source community and developed by that community. So it's an open source, as I've been saying, community-driven specification for enterprise Java microservices. And it's developed by a wide range of individuals, organizations, and vendors all collaborating within this Eclipse project to bring everything that you'd possibly need for microservices to the enterprise Java community. So as I mentioned, there's lots of different contributors to this project, some of which are vendors and organizations. So you can see here the wide variety of organizations contributing to this project. And as Jamie mentioned, that's one of the great factors about open source, is that flexibility and the fact that you're not locked into a specific vendor. You have the freedom and the flexibility to not only move across the software offered by all of these vendors because the underlying open source is shared, but also to be able to gain that innovation from all of these different vendors. So here are some of the implementations. Now, MicroProfile is a specification, which means you'll need an implementation to actually be able to use it. So there's lots offered by various different vendors from the previous page. And you can see here quite a few of them are actually open source as well, so you'll be able to use them for free. So here's a brief timeline. I say brief. It's a lot of information on this slide. But here's a timeline of essentially where the MicroProfile project has come from and where we're up to now. So it's gone through various different iterations, and over time, not only has the project sort of iterated upon the original APIs and components included in the very first MicroProfile, but it's also gradually added in more and more components and APIs as our infrastructure has progressed and our application evolution has progressed. And we've needed more and more of those APIs to be able to effectively deliver cloud-native MicroProfile. This is cloud-native microservices. So taking a look at what we actually get included, here is the MicroProfile 4.1 stack. Now, this is the latest release of MicroProfile with all of the latest versions of those components included in this diagram. This is the standard stack that you get as part of that 4.1 stack, and it includes a variety of Jakarta EE specifications, which we'll go into in a little bit, and also specific MicroProfile APIs and components. So it includes things like health checks, for example, metrics, which are obviously really important when you're distributing your microservices in this cloud environment, and you need to know whether they're healthy, whether they're up, and you want to get metrics back, for example, to be able to check on how your application is performing. It's also got things like configuration, so enabling external configuration to your application, which is an important factor in, say, the 12-factor app methodology that many of you might know. And it also includes things like fault tolerance, authentication, authorization, and what we're going to be taking a look at later is REST client. So as well as the standard stack, there's also standalone projects that you can take a look at that the MicroProfile community develops, and but isn't part of that standard stack as yet. So these are hopefully eventually going to be incorporated into that standard stack, but they're still developed by the same community, and they still provide some really fantastic sort of components and behavior for your microservices, like reactive behaviors, implementing things like GraphQL, context propagation, and long-running actions. So I mentioned Jakarta EE earlier, and Jakarta EE was at the base of that pyramid. Jakarta EE is another open source specification, and it is again held within the Eclipse Foundation, so it's an Eclipse project. It enables Java developers to be able to work on cloud-native Java enterprise applications and provides things like APIs and specification documents, TCKs, and compatible implementations. So it's sort of used in collaboration with MicroProfile when we're developing these cloud-native applications. Here's a brief timeline of Jakarta EE. It's essentially sort of the open source version of what was previously Java EE. So you can see here we started off at Jakarta EE 8, which was actually had identical APIs to Java EE 8. So you can see how they start to sort of marry up in terms of proprietary and open source. And you can see over time, again, we've developed this open source specification. We've had namespace changes, and yeah, it's just a constant evolution of improving upon this open source tech. And we're going to be making use of Jakarta EE specifications and also the MicroProfile specification in the lab we're going to show you later on. But I'll pass back to Jamie now to introduce some other of these open source technologies.
Cool, thank you, Grace. I have some questions I've seen in the chat about OpenLiberty, so I can hopefully answer them while I go through my slides. So OpenLiberty is essentially an open source runtime. A question in the chat was, are there any cases where WebSphere Liberty is better than OpenLiberty? No. So essentially, OpenLiberty is the open source project. This is built first, and then once this is built, OpenLiberty is built from that. Now, there are a few extra functionality and features in WebSphere Liberty, but they're not related to cloud native technologies. They're really stuff that kind of allowed WebSphere Liberty to run in a more traditional format. So by traditional, I mean using WebSphere network deployment and things like that. Now, if you are building cloud native applications with OpenLiberty, there should be nothing in WebSphere Liberty that is not available in OpenLiberty for you to use. It was a good question, and it took a lot of fighting with sales, etc., to basically get all this functionality into OpenLiberty, because they're scratching their head and wondering why we're giving away all our intellectual property for free. But it's a new world nowadays, and we wanted to make it open source, which we did. So it's pretty much identical to WebSphere Liberty. WebSphere Liberty just has some more older traditional functionality that you shouldn't need nowadays. So WebSphere Liberty, it's kind of an evolution. So WebSphere Application Server came around in 1998. It was a very different time in regards to how we deployed stuff and the general architectures we were using. So we were using monoliths, and we wanted an application server to stand up for a long time. So we've had clients and customers that have been running these things for 15 years without stopping. But we're not in that day and age anymore. We're in the day and age where we want to be very agile. We want to be making changes to our applications very quickly, rather than doing a release every 6 months or every year. And this is kind of where it's come from. WebSphere Liberty was introduced in 2012, and I think it was about 5 years ago now. WebSphere Liberty was completely open sourced, and again, there was only a few differences in regards to some of the more legacy kind of stuff. And as WebSphere has kind of transitioned and moved to WebSphere Liberty and then OpenLiberty, they've invested a lot in different open source technologies. So stuff like MicroProfile, Kubernetes, obviously running in OpenShift being IBM. So there is lots of different things which are kind of at the heart and some of the fundamentals of what we've been trying to build with OpenLiberty. So with OpenLiberty, we wanted to go back to the drawing board and really focus on the developer. So a focus on code, a way to make quick and fast iterative changes, want to make it really easy to write tests and true to production testing. So using other open source testing frameworks like Microshed testing and test containers. Then of course, it had to be container ready. And that was my first job at IBM, was containerizing WebSphere Liberty. And I think we were one of the first products in IBM to actually live inside a container, which was cool officially. And again, with tools and flexibility, we wanted to give you tools and give you the flexibility, so you can go and use loads of different types of build tools, depending on what you want. But you didn't have to use those. So really, we wanted to create something that was flexible, so you can use what you're comfortable with. Developer experience mode, or dev mode as we call it, is great because it allows you to essentially start your runtime and make changes to your your application code and your test code, or even add functionality to the server without having to restart the server or care about any of that. So it's great for developers because it means you can focus on writing your code, and the changes generally go live in about 0.1 seconds. So by the time you get back to your browser, those changes would have gone live. So it just makes us as developers a lot more productive. Again, focusing on developer productivity, and with a lot of these are open source technologies. So it works with the main IDEs. You've got Maven Central Repository or Docker Hub to get things from. You can use Maven or Gradle as your build tools, or you can even use Ant. And then it supports the main APIs, so Java EE, Jakarta EE, MicroProfile, and Spring Boot. It's really great with Spring Boot. I think if you compare it to Tomcat, it nearly has double the throughput, which is great because it means you would hopefully need to buy half the resources on your clouds and have half the application servers and half the microservices running. So do check it out if you are using Spring, because it can save you a lot of energy, a lot of money, sorry. Testing, again, supporting the main testing frameworks, and people do really like this product and this project. People that try it really, they're very happy to shout about it. So our job is to try and get people to try it out. So do give it a try. So OpenLiberty, this is where stuff has changed. So previously we used to have big application servers. They take, say, 10 minutes to start up or 15 minutes. Yes, they run for a very long time, but they weren't really a fit for in this world where we are paying for our resources on demand and we're using everything in containers. So with OpenLiberty, it's kind of went back to the drawing board and created something that's as small as possible, and then you add in the functionality you need. So for example, one simple place to configure everything, and then you just add in, for example, you see here the feature JSF 2.3. And again, in dev mode, you don't have to restart your application server. Your application server will know that you've added extra features, and it will go and install them for you without you having to do anything, which is cool. Has broad API support. So we generally try to be the first to certify in loads of different things. So Java EE7, Java EE8, Jakarta EE8, and most of the microprofile releases as well. A few other vendors may have beaten us with a few of them, but generally we've been the first to certify. And this is something that's kind of fundamental with OpenLiberty. We've noticed with WebSphere customers, people are on really old versions of our tech. And that's quite a shame for us, because we have, say, 350 developers creating new versions, adding new functionality, trying to make life easier for developers, and people are on really old versions. So with OpenLiberty, we really wanted to make it a zero migration kind of runtime. So you can write code on, say, Java EE7, Java EE8, or an old version of Java, and you can move it to the latest version of OpenLiberty and things should not break, which is great for you because it means as a developer, you get the latest versions of OpenLiberty, you get all the performance benefits, all the development benefits, and there isn't a massive amount of cost involved moving to the latest version, which I know can be a massive problem for some organizations. So our documentation is awesome. We have actually been talked about by other organizations as to how this is how documentation should be done. And we've moved away from like how we've traditionally done IBM documentation and created our own open source site. So we have over 50 different guides which talk about loads of different open source technologies. And some of these are actually available on an interactive website as well, which me and Grace will show you later. But it's really, we tried to make it as easy and simple to get started with this technology as possible. And the guides team have put a lot of effort into making this work. Does Liberty provide support for JMS? I think it does, yes. But I will double check after this. I'm pretty sure it does, yeah. So the OpenJ9 JVM, another open source technology, this time a JVM. So this was actually open sourced with OpenLiberty. And this was one of IBM's biggest open source contributions in history. It was over 1 million lines of code. And really they were open sourced at the same time because we wanted to kind of have different open source technologies that allow developers to really utilize the cloud native kind of methodology we use today. So the problem is with things like JVMs is they have lots of different characteristics. And if you tweak one of those characteristics, it could have detrimental effects on a different one. So getting the right balance between for like the cloud native world is difficult, because like I said, you can edit, say, startup time and make it lower, and it might make your throughput lower, etc. But I think with OpenJ9, the community has really hit the nail on the head, so to speak, and created something with the right characteristics for cloud native development. So, for example, it has a much faster startup time. And the startup time of your JVM and your application on the cloud is completely wasted resources. You're paying for those resources and you can't use them. Your users of your application can't use them. So getting your application started up is as quick as possible is fundamental. Of course, then you want a lower footprint at startup. You don't want it to be using loads of resources just to start up. Again, you want it to ramp up quickly. So the startup time, like I mentioned, is completely wasted resources. So if we can get to where we need to be quicker, then we're not wasting time and resources. And of course, we want it to have a smaller footprint during loads. I mentioned OpenLiberty with Spring is really good because, for example, it has nearly double the throughput of, say, using a Tomcat server. So that allows you to essentially have half the application servers, half the resources online, on the cloud. So it just makes your life a bit cheaper, essentially, and have less things to maintain. So OpenLiberty has been trying to chase this kind of 1 second startup time. And this wouldn't have happened if we weren't an open source technology and if OpenJ9 wasn't open source. So basically, we can put improvements into OpenJ9 and into OpenLiberty, which will allow us to take advantage of different technologies like at-in-time compiler and class cache sharing, etc. And this is just a comparison of, say, OpenLiberty runtime compared to a few others. As you can see, using OpenJ9 with class cache sharing brings our startup time down to about 1 second. Now, there are some extra technologies going into OpenJ9, which will allow us to get that even lower, down to about 0.2 seconds, maybe even lower, which is amazing because it will allow us to essentially enter this world where we can scale to zero and scale up very, very quickly. And like I mentioned, the time it takes for your application to start is essentially wasted resources for you. So, Grace, I'm going to pass it over to you to introduce the demo lab, and then I will take you through creating a RESTful web service.
Absolutely, thanks. So now that we've introduced you to these technologies, we've actually got 2 polls. So we'd love to know if you've had any experience with MicroProfile or OpenLiberty, which are 2 of the technologies we're going to be using within this lab today. That will help us set the pace for the lab and understand your general experience with these technologies in terms of, have you heard of them before? Maybe you've heard of them, but you've not used them. Maybe you've used them, but not in production, or maybe you're using them in production. So let us know via the polls, and we'll take a look just before we jump into the lab. Perfect. They're in the polls section as part of the Crowdcast. So the actual lab demo, what every developer likes to see, live code, using it in reality. So we've created a very simple application that we use, and we try and use the same application in all of our guides to try and make it straightforward for you to jump between guides. And instead of having to understand the application, you can just focus on learning the technology or the API or the component or the tools. So this application, as we said, we've tried to make it simple, to make it easy to understand the various components. So it's just a 2 microservices-based application. So you've got one microservice, which is called the system service, and that just returns the system property information for your host. And then you've got the inventory service, which tracks the number of systems you have, and it invokes the system microservice to retrieve information about the system, and it's then able to store that and display it. You can display it using a GET request. So that's our application that we're going to be using today. So the application we're doing, the lab that we're running through today, is going to be showing you how you can use some of these open source technologies to build a simple REST application. As I said, our guides build on top of each other. So if you're interested in checking out any of the other APIs here, whether that's the MicroProfile APIs or maybe more of the open source tech that Jamie mentioned, like microshed testing or how to deploy it into the cloud using some open source, we've got guides on all of those that build upon this REST application. So check those out afterwards. We'll put a link in the chat for that as well. The ones we're going to be focusing on today are a mixture of the Jakarta EE specifications and MicroProfile. So the first one we're going to take a look at is JAX-RS. So if you've not come across JAX-RS before, it stands for Jakarta RESTful Web Services. So as you can tell, helpful when we're building a REST application. So it supports the creation of RESTful web services that really, it comes with desirable properties like performance, scalability, modifiability. It uses annotations, as many of these components do. You'll see this reoccurring theme when using these open source technologies of using annotations to help simplify the development and deployment of web service clients and endpoints. So you can use annotations like app path to be able to state like a relative path, for example. You might be using app produce. So you can see some of these in our code here on the right-hand side. You might be using app produce, which states the HTTP response generated by your web service. Or there's others like app post, app get. App post is essentially used to create a new resource. App get is used to fetch that resource, for example. And we'll be showing you some of these in our demo today. We're also going to be making use of JSON-B and JSON-P. So if you've not come across these before, they stand for JavaScript Object Notation. That's the JSON part. And it is essentially sort of coming to be the go-to format for sharing data in microservice-based systems. So Jakarta EE provides two different API specifications for converting just plain Java objects to and from JSON data. So you've got the JSON-P, which stands for processing, and JSON-B that stands for binding. JSON-P provides a Java API for processing JSON formatted data. JSON-B then sort of builds upon this, and it provides a binding layer on top of JSON-P, making it even easier to convert objects to and from JSON. So again, we're going to be making use of this in the lab today. We've got a demo environment that you guys can use that we'll be using in the lab today. It's browser-based, which is great because it means you don't have to have any local prerequisites downloaded on your own machine. It's called the Skills Network Labs, and we've created this. It's just an IBM project that we've created for you to be able to have a sandbox environment to try out these technologies without having to worry about anything. You can log in with any social login, as you saw from the previous slide. And what you'll get when you log in is you'll get this sort of, I guess, user interface, you'd call it. You have an IDE on the right-hand side, and you've got instructions on the left-hand side, and you'll find your terminal at the bottom right-hand side. You'll be able to access this after the session as well. So as I said, if you want to try out any of those other labs that build on top of this, or just want to try this lab after the session, feel free to go on to the link that we'll give you and try those out. So here's the link you can use if you want to follow along whilst we do this lab. We will be going through it at sort of a fair pace, just because it helps us to get through the technology, doesn't keep people bored, etc. But if you want to go through it at a slower pace in your own time and really spend time on the instructions and on the code that we're implementing, totally fine. The link will be available afterwards, and you can do that in your own spare time. So I'm going to pass over to Jamie now, who's going to take you through this lab.
Okay, I hope everyone can see my screen. So like we mentioned, there will be a login. That is mainly to stop people Bitcoin mining on our systems. As much as we'd love to give, I'll post a link in the chat, 1 second. As much as we tried to build this without having any kind of login requirements, cryptocurrencies decided to be worth a fortune. So that's kind of why we have to do this. It's very simple. And again, you can use social logins to kind of get in. So you'll be brought to a page like this. Just click OK. This will then log you in. Just say, not pretend, I am not a robot, I promise. So I'll just log in and give it a few minutes. So this is a cloud native environment we've kind of built. It kind of came around before the pandemic when we were running workshops and people had issues, say, with their VPNs. They didn't have the right versions of the plugins. They might not have had the right version of Windows. So we wanted to create an environment that everyone could use. It was similar to what they normally use to develop with, but it had everything they need. So what essentially is when you create an account, a image is created for you. That is your environment image. And when you log in, it will essentially spin that up. And inside that image, we have a terminal, we have our IDE. In the terminal, we've got OpenJ9, we've got Maven, we've got Gradle, it's got Docker, it's got Kubernetes, and there is an OpenShift version of this environment as well. So it's pretty cool. And it allows everyone to kind of have the same experience. On the left-hand side, you have instructions, so you can navigate through them with these. You can change the size and the font, etc. And just to show you, you can quite easily get started by copying commands to your clipboard here, and then just pasting them down here. I'm already in that directory, so yeah. So what are we going to build today? So we're going to learn essentially how to build and test a simple REST service with JAX-RS and JSON-B, which will essentially expose the system, the JVM system properties of our host. And in this case, this will be the container we're running on in the cloud. Now, JSON-B is awesome because JSON-B takes a lot of the pain away from trying to convert a Java object or a Java data bean into JSON. So I say I've got two microservices. In this microservice, I can take my Java object, which in this instance will be a properties object, or the JVM properties, and JSON-B will convert that to JSON for me. And then I will send that to a different microservice, and that microservice using JSON-B will convert that back to a properties object. So when I'm sending objects around between different microservices, I don't have to sit there and worry about converting it to JSON, extracting the right information, parsing things. I can just chuck it a Java object, and on the other end, the other microservice, a Java object will come out. So it's awesome in that regards, basically. Okay, so let's get going. Again, this environment will be available after I've done this demo, or you can do it afterwards. You can follow along now, or you can just watch me go through it. To take it another step further, we actually have a module on deploying to Kubernetes, and then also adding extra things in, so a health check and configuring your microservices using Kubernetes. So let's get started. I'm going to clone down the Git repo we need for this project, and I'm going to run the try what you build section. So essentially, this will build our application. As part of that, it's going to go to Maven, download everything it needs, and then we're going to test out the application to see what the application should be doing once we've finished developing it. So this is just running OpenLiberty in normal mode, and once we see this message, it means our application server is ready to get started. Now, the first time you run this, it will take a bit longer because obviously it's got to download the runtime, it's got to download the microprofile dependencies and any other goodies it needs. But subsequent builds should be a lot faster because all this stuff will be in your Maven cache. So essentially, this is the URL we're going to be using. Now, of course, this is running in a container on Kubernetes on OpenShift in the IBM Cloud. So if I hit localhost from my browser, it's not going to go here because this is all running in a container. So what we have to do is we're going to run it from the terminal that's running from inside our container. Now, this terminal has the OpenLiberty service running, so we need to make a new one. Very simple, terminal, new terminal. And then I'm just going to hit this curl endpoints. If you double click these things, you can make them bigger, just to make it easier to see what the output. So I'm just going to hit that. These are the JVM system properties of the container we're running on, which is running in the IBM Cloud. And this is kind of what we want our microservice to do. It's very simple to achieve. So I'll take you through that quickly. So go back to your other terminal, just make sure you shut it down. I use Control-C. And then we can get going. You don't have to use Maven Liberty Stop. It's only if your service hung around or something like that. So let's go into the start directory. So there's two directories you'll find. So if we open up here, the projects tab, there's two directories in the repo we cloned down. We have a finished directory, which is what we just used, has the finished application, and the start directory. And this is where we'll be working from today. So I am going to run OpenLiberty in dev mode. As I mentioned, dev mode allows me to essentially start my runtime, start my application server, and not have to keep worrying about stopping and starting it all the time. It'll just make all my changes will go live straight away, which is awesome. It's taking a little bit of time because it's going to have to go and install essentially the Maven Liberty plugin, which we didn't have before, but it shouldn't take too long. And once it's up, so we're all good. Okay. So JAX-RS essentially has two key concepts for creating REST APIs. The most obvious one is the resource itself, which is modeled as a class. And the second is the actual JAX-RS application. And this groups all the exposed resources under a common path. So you can think of the JAX-RS application as kind of a wrapper around your resources. So this file should be already created for us. So if we go into the source directory, main Java, we should see a file here. Let me just make this a little bit bigger so we can read it. This is the system application. So what I want you to do from here is just simply copy the code here and paste it into here. If you see any warnings or errors coming up, don't worry, it's more to do with the environment rather than your application. So this is all done. So essentially what this is doing is just going to basically group APIs under this common path. So the common path will be system here. So if you look at the endpoint we hit earlier, we were using system, which is this path, and then underneath that we have our properties, which is the APIs or the endpoints we're wrapping underneath here. So I'm going to save this. As you can see, it's updated our application in 0.18 seconds. Awesome. So that's all good. Right, let me move on to the next one. So now we're going to create the JAX-RS resource itself, essentially the REST endpoint we're going to hit to get our system properties. So this command here, the touch command, will create a new file for you. Again, remember, don't run it in the terminal that's running your OpenLiberty service because it won't work. So we're going to run that. So that'll create as a new file. You can find the new file easily in the Project Explorer because it usually has a U next to it. Just allows you to find it a bit easier. And then we're going to copy in basically our application code. And like I said, it's very, very simple. If I save this, this should compile very quickly, again, deployed straight away. And what is this called? What is this code doing? So we have our path annotation. Essentially, this groups our methods here under this common path again. So like we saw, it'd be system/properties. And by making a GET request to this path, it will then invoke this method. So what happens here? Essentially, this is going to produce a media type of JSON. There are different types. You can produce plain text or XML, but with microservices, generally JSON is the preferred format. And here, all we're doing is essentially creating a properties, then calling the getProperties method, and then returning that. And again, JSONB handles basically that object being turned into JSON and output onto our terminal. So it makes our lives easy as a developer because we don't then have to worry about any of that. So that's cool. So yeah, like I mentioned, that's basically what the path annotation does. JAX-RS essentially maps the HTTP methods on the URL to the methods of the class, and that's all done by annotation. So like I said, using the get annotation, etc. And again, yeah, there's different media types, but we're going to use JSON. I'm just glossing over these instructions here rather than reading through all of them. But again, feel free to do this in your own time if you wanted to read the instructions more extensively. So next thing, I wanted to just talk about how easy it is to kind of configure OpenLiberty. So if we go to our Project Explorer view here, there is a Liberty directory, and in there is a server XML file. And this is pretty much the main file you use to configure the runtime. So what have we got in here? We've got the feature servlet 4.0. Well, we don't really want that. So we need the JAX-RS 2.1 feature here to make us be able to access our application. Then we've got some extra things defined. So we have, for example, as you can see, the HTTP port as an environment variable, HTTPS port as an environment variable, and also the context route. So this is basically your application name. These are all set as environment variables. So again, with this, I've removed a feature and added a feature. By saving this, OpenLiberty will know that, and it'll install what features I need. And a bit onto the point of the environment variables. Now, so you can configure, say, your HTTP port or your HTTPS port at this level. That's absolutely fine. But when you're managing lots, say tens or hundreds of microservices, you don't want to be configuring each microservice at kind of this runtime level. So by using environment variables, we can take these from our POM. So as you can see here in our POM, we have three variables set. So the port, the HTTPS port, and the project name, the context name. And the great thing about this is we can now do this on a build level. So when we build our microservices, as long as we're all set, we can set all these things at this level rather than having to dive into individual microservices to configure them. So it's great for utilizing things like that, essentially. So now technically, we should have a built application and it should work. So let's go back to this terminal. Let me just clear it. And then hopefully, if we run the same curl command as we ran earlier, we should get our JVM properties. So that's just really how simple and easy it is to use these open source technologies to achieve something simple or complex, depending on what you want to do. And it's really easy to get started with these concepts and these technologies, especially using our cloud native learning environment, Skills Network. So in regards to tests, I will very, very briefly go through this. So we can test the service manually by starting a server and visiting the URL. Great, yeah. But we want to automated tests because automated tests essentially allow us to find bug failures a lot quicker rather than us actually having to do graphical user interface testing. And really, who has time to do that much graphical user interface testing? So this is where kind of unit tests come in. So again, we can copy the touch commands and paste it into the terminal that is not running a process. So run that. That should create a test file. And as it did before, it's created a little U here. So it just allows you to navigate to it easily. So I'm just going to copy the test code in. Very basic test here. Essentially, we're using the JSON builder. This test class has quite a lot of lines, but it's not too bad. And it's basically indicated with the @test annotation at the top. Now, the main things to note here, I'm not going to read through all these instructions, but the main things to note here are essentially, first of all, we're getting the system properties again. So we're getting the port and we're getting the context route. And this is important because we don't want to hard code things like the port or the application name into our tests, because it means if we move to an environment where the port's changed or the context route's changed, then all our tests are going to break. So rather than do that, we can get them as environment variables like we've done here, like we did in the server XML. So we don't have to hard code these things into our test. And then really all we're kind of doing here is creating a web target. The response is essentially a response object, which we will get back. So here as you can see, we're using assert equals, and we're essentially just checking that the response we're getting back from our request has the right status code. And that can be done like this. And if it does, then our test pass. And if it doesn't, then obviously our test fail. So very, very simple to get started with tests, testing these kind of microservices. As you can see, it knows, basically I made a test class. If I save it now, it will know the tests I've compiled okay. Now with OpenLiberty, we didn't want to have to rerun your testing cycle every time you make a tiny change because you might have loads and loads of tests. What you can do is just go to your terminal, hit enter, and run your testing cycle just like that. Now, the first time, again, this is running its tests. It's downloading things from Maven. I started this environment with a completely fresh environment, so the Maven cache or anything wasn't populated. But once all that's done, it should run very, very quickly. So if I just go back to my terminal and hit enter, it'll run my tests again, just like that, which is great because it means I can get feedback from my changes quite quickly. That's pretty much everything from this environment. And again, the main things I wanted you to take away is how easy it is to get started with these technologies. So again, under here, we have OpenJ9, which completely open source JVM, which can massively reduce your startup time and increase your throughput. And switching JVM is quite an easy thing to do. So I do suggest just try a different JVM. If you're familiar or you use Eclipse, then switching to just say an OpenJ9 JVM can actually increase your startup time of your IDE. So just simple things like that make life a lot easier for us. And as a developer, if we all switched around the world to use a JVM or a runtime which is more performant, and even saved us a small amount of resources, we could save so much money and so much energy around the world. And we're engineers, so it's kind of our job to kind of figure these things out. So like I said, that was kind of just my brief overview of creating a simple REST service using Jakarta EE and MicroProfile. Again, these will be available after the workshop, so feel free to try any of the others. And with that, I think I will return to Grace so she can finish off the presentation.
Great, thanks. So as a recap, what have we sort of learned from this session today? So we've had an overview of these various different open source technologies within the Java ecosystem that can really help us build effective cloud native applications. So for example, with MicroProfile, in fact, with pretty much all of these, the great part about the fact that they're open source is that you don't have any vendor lock-in. So you have great flexibility in terms of the software stacks that you use, where you run your application, how you build it, and potentially switching at some point. MicroProfile also gives you a full set of cloud-ready APIs that you can utilize that we showed you in the stack that we saw. And there's a really big community developing it and contributing continuous innovation and evolution into that project. Jakarta EE is another open source enterprise Java set of specifications of APIs. Again, no vendor lock-in and another large community developing that software. Then you've got OpenLiberty. As Jamie went through, some great benefits of using that. So you've got modular application server, the fact that it's really lightweight, the fact that it's easy to configure, it's certified against Jakarta. And as Jamie mentioned, we always try and be the first to certify in many of these different aspects. It's production ready and there are official Docker images available and it's optimized for development, as Jamie showed with dev mode in that demo. And then we've got OpenJ9 under the covers. As Jamie mentioned, there are some great performance benefits to utilizing OpenJ9. So the fact that it has a really low memory footprint, fast startup times, really high application throughput, smoother ramp up in the cloud, and it's easy to use Docker images. If you want to check out more about any of these projects, we have some additional links for you to go away and take a look at if you're interested. And they link off to some of the sort of open source homepages as well. So in terms of links and additional materials, here are the links that I mentioned. So if you're interested in MicroProfile, there is a starter project that you can use. So head on to that first link. We've got a whole series on IBM Developer around what is MicroProfile. So if you want to check out more about that and more about the individual APIs, then check out the resources we have there. We've also got the OpenLiberty site. There is a starter project for that if you're interested as well. And you can find all of the guides, which are where all of the labs come from, on our website as well. So if you wanted to check out any more of those labs, we have cloud-hosted versions as well as locally hosted versions, depending on what environment you'd like to try out those technologies on. And then some other resources there for OpenJ9 and Jakarta EE. So with that, thank you guys very much for listening. As we said, I'm Grace Jansen, and I'm here with Jamie Coleman. If we haven't been able to answer any questions you have during this session, or maybe you think of questions later down the line, then let us know via Twitter. Our Twitter handles are there, and you can contact us anytime. Thanks for listening.
Thank you, everybody.
Amazing session. That's absolutely fantastic. Thank you very much, Grace and Jamie.
Thanks,
Miriam, are you going to pop up?
Yes, sorry, my toggle audio and video was being slow. So we do have a couple of questions in the chat. One is a general one. Is this session being recorded? I forgot to say at the start. Yes, they're all being recorded. All the sessions of the Developer Festival are being recorded. So once the live stream ends, you'll be able to hit refresh and watch it all over again and again and again. So that's no problem. If you missed anything or you want to watch it again, yes, all sessions are being recorded. They're all available, all recordings with the same URL. So if you hit refresh after we finish the live stream, you can watch it to your heart's content.
Indeed. So there are a few
Super,
questions. Oh, sorry. Go on, Miriam.
No, go for it.
Okay, I was going to say, we have got a couple of questions. Now, this is streamed across multiple channels. So for those watching that are not on Crowdcast, a question came in asking, what do you think about projects on native compilation? Now, in the chat, both Grace and Jamie have answered this, but can you just go over what you said?
So we have an article on IBM Developer that goes into this in a lot more detail. So if you'd like a fully comprehensive answer to which runtime you should be using for your applications, that's a fantastic article to go to. It's actually called Choose the Right Java Runtime for the Job. So it sort of says in the name why it's appropriate. But essentially, cloud native compilation is great and it does have advantages. However, there are limitations to using cloud native compilation. As Jamie said in the chat, there are certain aspects of Java that you aren't able to use at the moment and aren't supported with cloud native compilation. So if you've already got an application that's using the full set of Java EE APIs, and there are certain APIs, for example, that you're already using in your application that aren't supported, moving to cloud native compilation is not necessarily going to be a good fit for your application modernization journey. However, if you're creating an application from scratch, you don't have any history in terms of using Java EE APIs, you don't have a need for the APIs that aren't supported, and you're creating, say, microservices or especially functions, that really fast startup time with cloud native compilation might be a really good choice for you. So this is why it's really dependent on your application, the needs that you have within your application, what stage you're at in your modernization journey, and the APIs that you need supported. In fact, Jamie mentioned this in his comment. the OpenJ9 community is actually working on achieving this really fast startup time that is going to be hopefully comparable to cloud native compilation with a full JVM. So that's an interesting sort of project that's going on at the moment, and innovation that's happening within that space that might be of interest. But they're the main points I'd say. Is it depends on your application, depends on the APIs you need supported, and depends on what stage you're at. Jamie, do you want to add anything else?
Yeah, I was just going to say, yeah, you pretty much covered everything. It's quite a big topic. I did an hour presentation on this last week, so it's going to be a lot to squeeze out of one question. But yeah, pretty much. I mean, native technologies, they're great, but they have limitations. And so people in the actual Java community want to remove those, well, bring those benefits to essentially the OpenJ9 community. So yeah, that's kind of what we're working on at the moment.
Watch that space.
Yeah, definitely.
Fantastic answer. Thank you. We have another question, and from Grace Lowe, who said, Jamie mentioned energy savings. Is there a tool to estimate the energy saved or used with the resulting processes and JVMs so that developers could optimize that per process?
Yeah, I wish. So this has been a subject, a popular thing in my head for quite a while. When I started looking at microservices with Java, of course, JVMs are a kind of overhead. There's something we have to have there in every microservice. So I really started to look into kind of different ways we can make our microservices more performant in Java. Unfortunately, no, there is no tools or technology that focus on energy saving whatsoever. It's really done as an afterthought because most people think about money when they think of the clouds. They don't think about energy. And doing a lot of research into this, turns out these data centers, they use quite a lot of the world's energy. So I really started looking into different ways and ways we can try and cut down our energy usage, because we are engineers at the end of the day. It's our kind of responsibility to come up with these things rather than use technologies that use too much energy. And there are loads of things you can do to your JVM. I do have talks on tweaking your JVM to get the most performance out of it and reduce your footprint, your carbon footprint, and reduce the amount of money you're spending on the cloud. But no, this subject has not been given enough attention, and unfortunately, no, I haven't found a tool which measures this. Now, we have inside IBM and even in WebSphere put kind of meters on the sockets in our data center to try and see how much energy drain we're getting from some of our test systems. But other than that, no, there really isn't anything. So if you do find anything, Grace, please do let me know, because I'd love to shout about it. I'd love to test it. I'd love to try it out. But the short answer is no. Sorry.
Thank you very much for that. I mean, to me, that just sounds like an open source project in the making, really. So take that as you wish. We've got one more question from the chat, and it's how can they get access to the slides?
So we can share them on SlideShare. That's absolutely fine. And then we can tweet about it, and you can just follow the link through that tweet. That's probably the easiest way, if you guys are okay with that.
Yep. And we've got a GitHub with all the talks and sessions for Developer Festival. And so I'll include the link there too.
Perfect.
Sweet.
Fantastic. Thanks. Absolutely bang on time. That's fantastic. Yes, thank you very much, Jamie and Grace.
Thanks so much for having us.
Yeah, thank you. Bye, everybody. Enjoy the rest of the festival.
Bye.
Right then. So what have we got up next? Anything to add, Miriam, before we get on with the next one?
So just a quick note while our speakers are joining. If you're just joined us today now in the Developer Festival, welcome to you. We've just had our first session, Open Source in the World of Java, and next up is Project Debater.
Yes, so we have got Alvaro, Yamini, and Adam, who are data scientists from the IBM Client Engineering team. And this is where we'll see them analyze medical transcripts using Project Debater. So everybody join on the screen.
So I see Adam and Yamini have accepted and are connecting, so we'll just give them a few moments to join.
Fantastic. Right, they should just pop up on the screen once they've joined, won't they?
Yeah.
Yeah, that's brilliant. We give them a few moments.
Just going to try sending again. Needs to be.
Miriam, we have a question in the chat. What is the GitHub link for the slides?
Great question. I will post that in the chat in just a second. It was in the email. If I recognize, Rachana, your name. It was in the email that we sent out this morning as well. But I'll be able to put it in the chat in just a second.
Fantastic. Adam has joined. Hello, Adam.
Hello.
Hello, Alvaro.
Oh,
I guess we're just waiting now for Yamini. Hello, Yamini.
there she is.
Hi everyone.
Hello.
Sorry about this. Yeah.
Okay, so like I said, you're going to be using Project Beta for medical transcripts. So we will drop off the screen and let you get on with your workshop.
Thank you. Thanks, Liam. Just going to share my screen. Yeah, hopefully you can all see my screen. Is that all okay? Okay, I'm just going to get started. Right. Thanks everyone for joining us today. And I'm Yamini Rao, the data scientist with IBM Client Engineering. And with me, I have my colleagues Alvaro Corrales and Adam Green as well. And today, as Liam mentioned, we are going to be talking about analyzing medical transcriptions with IBM's Project Beta. We are going to be working through Jupyter Notebooks and a web application, which is built on Streamlit. I'm going to start off with a quick introduction with a few slides, and then we can jump right into the Jupyter Notebooks. So just to give you a quick introduction about our team, we are part of IBM Client Engineering, which comprises of various multidisciplinary teams, and we work in a co-creation method along with the client to build innovative solutions. Now, this here is a typical example of a client and IBM squad competition that work together on a project. And we, the three of us specifically, are part of the data team, which comprises of data scientists and data engineers. Now, we have these multiple different teams who work in tandem to deliver these transformational solutions that bring value to the client's business. A little bit about our approach. So using different methodologies such as design thinking, agile, and lean startup, the idea is to launch an MVP, which is a minimum viable product that proves the value of the client's vision and is also technically feasible. Now, at its core, it's a collaborative partnership between clients and IBM and uses an outcome-first, data-driven methodology to deliver outcomes. So yeah, this was a quick introduction about our team, IBM Client Engineering. Moving on to today's topic, Project Beta. I'm going to give you a quick introduction, tell you about how it came to be. Now, Project Beta continues a tradition of IBM research grand challenges. Now, IBM has had a few grand challenges in the past. In 1997, we had a supercomputer called Deep Blue, and then in 2011, there was IBM Watson, which a lot of you would have heard of. Which beat the all-time human champion in the Jeopardy trivia TV show. And then following suit was Project Beta, which was developed by a team in Haifa Research Lab in Israel. Now, and also together with other joint collaboration with other IBM research labs across the world as well. And this system was demonstrated in February 2019, where it successfully was involved in a debate with some champion debaters. And since then, Project Debater has transitioned from a technology showcase in the context of a competitive debate into a business asset which is designed to assist people in decision making. Now, as an early access program, I will leave some links. You should probably see some links in the chat now, which will be shared. The links to the research paper for you to get more information about the debate itself that happened in 2019. A little more information about the early access program, using which you can get access to the Project Debater APIs. And there should also be a link to the GitHub repo about all the information that we are going to be sharing today. Right, moving on to the next slide. So Project Debater, as mentioned, now has 12 core APIs that you can use. And the first group, of course, is its core NLU services. A little bit, I'm not going to go into a lot of detail about each of these services, but I'm going to talk about text wikification because that's something we will be using in our use case today. So now the text wikification service is a service that gets a text and returns a list of mentions of Wikipedia concepts in your text. And that's something we will be using today. And again, you have your concept relatedness, text clustering, sorry, there's a typo, and common theme extraction. And the second group of APIs is about argument mining and analysis. So this helps in identifying arguments, evidence, and claims, analyzing their stance, and assessing their quality. So this is about the second group. And of course, the last group is about content summarization. So you have your narrative generation and key point analysis, which are two high-level services that create different types of summaries. In today's use case, we are specifically focusing on key point analysis. A little bit more about what key point analysis is. So this is a unique summarization paradigm that includes an important quantitative angle to it. So what this service does is it summarizes a collection of concepts on a given topic as a small set of automatically extracted human relatable key points. Now, it can be applied to different types of opinionated texts like user reviews, customer feedback, survey responses, and posts on social media, for example. But it's not limited to these use cases, of course, as you will see with today's example. So the key point analysis allows you as a user to automatically extract high quality and informative opinions from thousands of user inputs, and it also allows you to see how predominant each opinion is. So this is a bit about the key point analysis, and this of course will make a lot more sense once we delve deeper into our use case today. So so today's use case, what we're doing is we've picked up a public data set from Kaggle, which has medical transcriptions, and we are using the key point analysis API to extract specific key points from these medical transcriptions. And what we're also doing is using some demographic data, which includes information about London boroughs, and using this to correlate them with these medical transcriptions and the key points that we extract out of the Project Debater APIs, and sort of correlate both of these, which will help with a use case for population health management. And a lot of this you will see towards the end when we demonstrate the application as well. You will see how all of these are tied together. So today's use case uses this public data set from Kaggle. We are also going to be sharing the link using which you can download the original data set, and also the data set which includes information about London boroughs as well. So this is about today's use case. And I'm just going to quickly switch to my notebook. So I've just switched to Watson Studio, and this was just a quick introduction about what Project Debater was, a little bit about key point analysis. And in today's use case, as I mentioned, we are going to be using the public dataset, a little bit about the GitHub repo. Sorry, just bring this up. So the link is in the chat, as you can see. So all of the information that we are going to be talking through today is all available within this GitHub repository. So you've got the early access program. So ideally, this you will need to request for an API key to get access to the SDK and all of the different APIs within Project Debater. So you can do that by using this link right here to request for an API key. And all of the different steps, I'm going to be using Watson Studio on IBM Cloud to run my Jupyter Notebook. And all of the steps to sign up to your cloud account, set up your Watson Studio service, and how you can load a notebook is all mentioned in this link. There is a link to, you can upload your notebook using, using a URL. So let me just show you where the notebooks are. So all of the information, the data that we're using, the notebooks and the application are all available in these folders within the GitHub repo. So yeah, that's just a little bit of admin. So I'm going to shift back to my notebook. I'm going to quickly run through, this notebook. I have completed running the notebook entirely just in the interest of time. So we will walk through each of these cells. Again, everything you need, all of the links are also referenced within the notebook. And oh, yes, thanks, Max. That's something I should have done. I'm gonna mask that. It's okay. Yeah, hopefully nobody still take it. But yeah, it's not in the notebook that's on the GitHub repository. So don't worry, the API keys can take it out. So you will need to request your your API key, which you can use within this notebook. So right. So the first cell, what we're doing here is we are installing the SDK. And I also have an eye on the chat. So if you have any questions, you can leave them in the chat or using the Ask a Question tab, and we can address all of your questions towards the end of the session. So right, so the first cell here is of course we're installing the SDK. This is available on on IBM Cloud, for academic use. You can also request this for commercial use with a license, via that website as well. So yeah, this bit is just uploading the data sets that we're using and also installing the SDK that's needed. In the next cell, we're importing our required packages, our Python packages that we will be using throughout the notebook, and also uploading, and converting our data set into a data frame. And and in the next cell, we are initializing the client. So before running the key point analysis service, we would need to initialize our client. And the Debater API object supplies the clients for the various Debater services. So this bit right here. So yeah, so the Debater API object is configured with the API key, which you will use, that you've requested, and it should be, it's from that early access program website. And in this case, it's passed to the environment variable, Debater API key, and we then obtain the key point client from the Debater API object, right? That's what we're doing there. And so the key point analysis service stores the data in a domain, and user can create several domains for each for a different data set. So here we are calling our domain the medical demo, and domains are only accessible to the user who created them. Right. So in the next step, what we are doing is now, in order to improve the coverage and the quality of our results, we are going to run, the argument quality service and select 1,000 sentences with like top quality sentences, basically. So what the service does is it receives pairs of your sentence versus your topic and returns a score indicating whether the sentence is phrased, if it's phrased grammatically correct, or if it's clear and concise, it has clear and concise language, etc. So the ranking of the quality is based on the machine learning model, which was trained on human assessments of over 30,000 arguments. So that's how it was trained. And what we're doing is running the argument quality service to pick our top 1,000 top quality sentences, right? So once that's done, we are running our key point analysis service over these top 1,000 sentences. And in this bit, we are, we're including two main parameters: the number of key points that we want to extract from these sentences, which are 20, and the mapping threshold, which is 95 here, but the default is 99. I will leave a link to this page as well, which has all of the different parameters that you can use within, for your application. We are using these two parameters, the mapping threshold and the number of key points. You can of course change these depending on the number of sentences you have and the amount of coverage that you'd need. So, so mapping threshold basically is responsible for deciding whether a sentence matches a key point, or how much a sentence matches a key point. So therefore, reducing the threshold from 99, which is the default, makes more sentences match key points. It increases the coverage. So we've reduced it from 99 to 95. But of course, this also comes with the risk of reducing the precision. So you would need to, take care of, have like a comfortable value, not to reduce the precision as well. So the mapping threshold refers to, how relevant each sentence is to a specific key point. So it's a very important parameter to include. And once that's done, we run our key point analysis service over these top 1,000 sentences. And this is our output here. As you can see, we have all of these key points that have been extracted from these different sentence clusters, as we call it. So each of these have a specific key point that is related to these different sentences. Now, this is, so these are all the 20 key points that we've extracted. And in the next cell, all we're doing is we're just putting our results in a data frame, to make it better readable. And the next step, we are merging our output from the key point analysis. So this is our output. You have your key points, your sentence text, and some other arguments that have been returned by key point analysis. And this is our original data set that we uploaded into the notebook. And what we're doing here is just merging both of these data sets to include our original data set along with the different key points that have been extracted for the different sentences. And this is just a quick visualization to give you an idea of the different key points and the number of occurrences there are within our data set and how it's classified. And coming to a few visualizations. So here, what we're doing is we are clustering each of the key points depending on the medical specialty. Now, keep in mind, this is in relation with the actual ground truth, and this is not an input that we are providing, and this is in relation to the actual ground truth. So you can see each of these key points are rightly classified in relation to the actual medical specialty they belong to. So for example, if you see this patient may have had reactive arthritis, it's been rightly classified under an orthopedic issue. And of course, it has other relevant issues as well, but of course, the most relevant category has been assigned first. So this is in relation to the actual ground truth. So all of these key points, if you go through them, you can see this one is in relation to hemorrhage, and so it's also rightly classified based on what medical specialty each of these key points refer to. So that is, again, there's a different map for each key point that has been extracted. And this is again a map to give you an idea of the different medical specialties that are available, which are also mapped in reference with the key point. And that's just a visualization. And in the next cell, we've got we are using the other API, which I briefly mentioned about in the introduction, which was the term wikification, and the API is called term wikifier. Now, what this service does is it runs over the sentences and identifies the Wikipedia concepts that are referenced by phrases in the sentence text. So these different concepts correspond to different Wikipedia articles. Each occurrence of a concept in the sentence is called a domain, which you will see. sorry, it's called a mention, which you will see here. And so now, so what we can do, what we are doing here is we are using the term Wikifier API to extract all the mentions in the sentences. And once, let me just go through the visualization, which will make more sense. So once you come down, so you can see each of these. So if you take, for example, this cluster here, this key point says baby boy has significant pulmonary hypertension. So the team Wikifier has classified articles or key Wikipedia concepts that are reference to hypertension. And the idea for this is to get into, to sort of understand the key points better or get into a more deeper analysis of the key point. Because as you can see, this API does not only bring up concepts that are referenced in the key points, but it also brings up other relevant key points that are related to the original key point as well. So for example, this not only mentions hypertension, but also chest pain and lung chronic condition, palpitations, etc., which are not referenced in the key point, but the term Wikifier automatically picks up different Wikipedia concepts that are related to keywords within your key point. So this obviously helps you to delve a little deeper and help understand your key points a lot better. So yeah, so if you go through all of these different examples, you can see there's hemorrhage, and it's not just hemorrhoids, but there's bleeding, wounds, abscess, all of these different different terms that have also been sort of classified in this visualization. So Term Wikifier brings up related concepts as well to help you understand the different key points better and delve deeper into your analysis. Now, we've not done this here, of course, but there is another API called Term Relator. So what you can do is use the Term Relator API to see how each of these terms are loosely or closely related to each other, and you can also get to the bottom of your analysis using the Term Relator. So you can delve a little bit deeper into all what the key points mean and what's been extracted from your from the key point analysis. Right, so this is the end of this notebook. So just to give you a quick recap, what we've done is just giving you a quick introduction about Project Debater and how you can access the API key using which you can download the SDK and get access to all of the different APIs, and then run your key point analysis over the different sentences in our public data set. And all of this is again in the GitHub repo. And I'm going to hand it over to Adam, who is going to talk about a little bit about the coherence scores for key point analysis and also see how we can compare key point analysis with an open source topic model like LDA. Over to you, Adam.
Thank you, Yamini. Yeah, I'll share my screen. Can you see my screen okay? I'll take that as a yes. So hello. Thanks for that, Yamini. So Yamini, as you mentioned, she talked through what key point analysis is and generally how to use it. I'm going to talk a bit more about how we can assess the quality of the key point analysis models that we develop. That's really important because it allows us to do two things. One is to compare different models with different parameters, and that allows us to tune the parameters and select the optimal ones that give us the best key point analysis model. And then secondly, it allows us to compare key point analysis to other types of topic models, like latent dirichlet allocation, which I'll talk a bit about later. So in terms of the quality of the model, there's two ways to analyze it. One is qualitative, so that's really a human looking at the output of the key point analysis and trying to understand, does it make sense? Do the key points relate to the topics properly? And can I understand what each of the key points is actually means? If you've got a large selection of different key point analysis models, it doesn't make sense for a human to be doing that and analyzing them, because it's so subjective that it's hard for a human to say one model is better than the other. So really you need some sort of quantitative measure that will allow you to objectively compare different key point analysis models. So in this case, there are lots of different measures that you could use depending on what you wanted from the model and how it was going to be used. In our case, we've used model coherence. So these are a way to kind of estimate how interpretable a topic is for a human. So as an example, if this is a topic and these are the words associated with it, in this case, the words brain, hemorrhage, Alzheimer's, dementia, all related to the brain. These words probably occur commonly together within the documents. So this would be considered as having a high coherence and a high interpretability. Whereas if the topic was actually brain, knee, gastric, tendon, then we might say that's low coherence, doesn't really make sense. It's just a lot of random words. So our assumption is that if we have a high coherence score, then the model is more interpretable and more usable. And obviously that is an assumption. It's not necessarily true, but it's sort of what we're going to work from. So I'll take you through a notebook now. So we have this notebook here that's quite useful. So there's kind of two main parts to it. One is the hyperparameter tuning for the key point analysis, just an example of how you can choose those, and then also benchmarking it against the LDA topic modeling. So the two main quantitative measures that we focused on, as I mentioned, coherence. So there's lots of different ways you can actually measure coherence, but we've used, it's called CV coherence, and it gives you a score between 0 and 1. 1 being highly coherent, 0 being not coherent at all. And then we also look at the coverage, which is important for key point analysis. So you put in a list of sentences and it will give you a list of key points and the sentences assigned to each key point. But with key point analysis, it doesn't assign every sentence to a key point. If it thinks a sentence isn't useful, doesn't add any information, doesn't really fit into any category, then it won't assign that. So the coverage is the proportion of sentences that were actually assigned to a key point. And the coverage will change as we change the parameters that will also change the coherence. And that's why we look at them together. So in terms of this notebook, I've run this before, so I'm not going to run it now because some parts do take quite a while to run. But it's essentially the setup is the same as Yamini's. The one difference is that you can specify the number of cores that you want it to run on. So calculating coherence can be quite computationally intense. So running on multiple cores can help. And then we import the packages. So here, because we're doing more kind of like it's very like natural language processing type stuff, we're removing certain stop words from the data that don't give us information, and this is required for calculating the coherence. So words like I, me, my, myself, we don't really want them. They don't actually add any information, so we will remove those. So now we initialize the API, and then we move into the hyperparameter tuning and model selection. So the main two like parameters that we focused on in this section as just examples really are the number of key points. So this is the maximum number of key points that the model can give you. And then the mapping threshold. So this relates to when the model is assigning sentences to key points, it will calculate a match score to each key point. So that's a value between 0 and 1. The mapping threshold is the minimum match score required to map a sentence to a key point. So having a really high mapping threshold sets a really high bar for the sentences to be assigned to key points. So in theory, they should match them to a higher quality, but you'll also result in more sentences being unassigned. And there are like several other parameters you can tune, like you can filter out sentences of certain length and so on. You can filter out sentences that aren't of a high enough argument quality score and so on. So in terms of, there's some common functions. I won't go through all of this code, but like I said, you can access these notebooks. But we essentially define a function that will run key point analysis and give us an output with parameters that we can input. And then we also define a function that will score the key point analysis. So it will output the coverage and calculate that, which is a simple calculation. Calculating the coherence is a little bit more complicated. So coherence is designed for more standard topic modeling algorithms where each topic is associated with a collection of words. So if a sentence contained a lot of those words, then you'd assign it to that topic. In key point analysis, we have the key points, which is a sentence, and then they're associated with a collection of sentences rather than words. So what we have to do is we have to do some pre-processing to transform these sentences into tokenized just lists of words, essentially. So we do things like we remove all the punctuation, we just apply some pre-processing, remove stop words and so on. And what that allows us to do is it allows us to transform the key point analysis output into a more standard topic modeling format, which then we can calculate the coherence of. So looking at the first one, so here we just import the data, and then this function does a grid search for the number of key points. So it will, if you put the minimum key points as 10 and the maximum as 20, it would generate a key point analysis model for 10, 11, 12, all the way up to 20 maximum key points. And it will return the coherence score and the coverage of those. So if we plot this, we can see that as the number of key points increases from 1 to 25, the coherence actually decreases and the coverage increases. And this makes sense because the first key point is probably the highest quality. And as you add more key points, you're assigning more sentences, so the coverage is increasing. But not all of those sentences fit as nicely into those clusters. So that seems to decrease the coverage. One point you can make as well is that once you get to the parameter is the maximum number of key points. So if you specified 100 key points for this case, it would still only output 22 key points. So once you get past a certain level, there aren't enough candidates that make nice key points that you can assign other sentences to. So that's why it's the maximum number of key points. And then we can repeat the same, but using the mapping threshold rather than the number of key points. So you can see here, as the mapping threshold gets really close to 1, the coverage really drops off quickly because there's such a high benchmark criteria required to be able to assign a sentence to a key point. And that also results in the coverage, the coherence decreasing. So the coherence mostly stays flat until you get to a really high mapping threshold, which is quite interesting. So like I said, you can repeat this for other types of parameters as well. So now we move on to the benchmarking. So here we're comparing key point analysis against a more standard topic modeling algorithm, which is latent dirichlet allocation, LDA. So like I said before, this assigns each topic has a collection of words associated with it. And it also quantifies how much each word contributes to that topic. So we can build an LDA model here. I won't go through the code too much because this isn't really the focus. We're more focusing on the key point analysis. But essentially what we do is we apply some pre-processing. Here we're doing parameter tuning. So we build a lot of different LDA models. That takes quite a while to run. Then we rebuild the best model based on our parameter tuning. And here you can actually visualize the output. So as I mentioned, you can see here it's just a collection of words and how much each word essentially contributes to each cluster. So this is one cluster. It can be quite hard to interpret this. So it's like bilateral pain, old, year, cervical, anterior, fixation. It's quite hard for a human to look at this and interpret it, which I'll talk a bit more about later. But From that, we can calculate the coherence score. And then we can repeat the same for key point analysis. So we do it here with 20 key points and a mapping threshold of 0.9. So what this tells us is that the key point analysis coherence score is actually quite a bit higher, which is good. So it's 0.665 compared to the LDA, which has 0.41. So in this case, it did outperform LDA. It's not quite a like-for-like comparison because, like I said, key point analysis outputs a list of sentences rather than a list of words and how much they contribute to those topics. So it's not quite a fair comparison, but it does give some evidence that key point analysis is high performing and the results of it are really interpretable. And there's a few reasons for these differences that we can also consider. One is that we use the argument quality score to only select the top 1,000 sentences. So we can argue that by removing a lot of the low quality sentences, we can improve our results. Whereas in LDA, they have to assign, everything has to be assigned to a cluster. And that's the second point as well, brings me on to nicely, which is that key point analysis doesn't assign everything to a cluster, whereas standard topic models generally will. And that means that even if a sentence doesn't fit nicely into a cluster, it will still be assigned to that. Whereas key point analysis just avoids that whole issue and just removes them and says these don't actually help us in interpreting the result. And I think another reason why you might prefer key point analysis over kind of standard topic modeling is, as I mentioned, that each key point is assigned a list of sentences that a user can read through and read what sentences, what they're saying, and understand how they relate to the key point. Whereas it's a lot harder to interpret, like here, when you've just got a list of words and you have to try and understand what this topic is. So that's just a bit of an example about how you can do that. I'll pass over now to Alvaro, who's going to talk a bit about how a client might use this key point analysis output.
Thank you, Adam. Thanks a lot. Okay, let me share my screen. Okay, so hopefully you can see my screen now. And yeah, so I'm going to be talking now about how we can use this this service in a real business case scenario. So the use case that we have chosen is population health management. So this means someone in the policymaking space, or someone in charge of governance, or in charge of overseeing different hospitals or different health indicators in a region may be interested in seeing what's going on in the internal documents or in the thousands of documents that are produced every day by the different hospitals or GP practices in the region. So it could be useful for them to kind of have a summary of all those texts and see how they relate to what's going on in that area in terms of health indicators. Now, a couple of disclaimers before I start the demo. This demo app that we are showing you here is not meant to replace a doctor's judgment. It's almost like don't do this at home. A doctor is a professional. We're just showing here correlations. We're showing here the results of or what the data is telling us. But in the end, it's a doctor who has to make a decision. And also on a more kind of techy or data side, remember that we are using medical transcriptions from a data set in Kaggle. This data set is open source, of course, but it's also anonymized. So we don't have information about who the transcription is about, or the doctor who wrote it. We don't have any information about region, the country, or whatever, and we don't have information about dates. But because we are doing a population health management kind of demo or experiment, we could use some of that information. And in particular, geographical and time information are quite useful in this case. So we have assigned a random borough of London and a random year to each observation so that we can visualize what a potential use case for this technology could be. Now, having said that, we can dive into this demo app and have a bit of fun with our key point analysis. Okay, so as you can see in this app, we have 3 tabs. The first one is the one that you are seeing now. We're also going to go through each 3 of them, and we can kind of play a little bit with the parameters of the model. In particular, here we are playing with the key points that we are selecting in our that we are dividing our sample into. We have chosen 15. It could have been 20, or it could have been 3. This is a bit of a kind of finger in the air type of choice, but if you think of coherence, what Adam was talking about just a minute ago, you could base your information on what number of key points to select based on coherence, for instance. And then we're also kind of visualizing the results for year 2016. Now let's move on to the homepage. As you can see here, after running the model with these parameters, we end up with 15 topics plus 1 non-topic. Remember that key point analysis doesn't allocate a sentence to a topic if it doesn't make sense for that sentence to be in that topic. So we end up having a none kind of cluster. You can see that the topics are quite kind of diverse in terms of the information that they contain. So some are about fever and otitis media. Some are about gastroesophageal reflux, so things related to the stomach, polyps, so it's more of other things. But we have quite a variety of topics. So the model is picking kind of different diseases and clustering them quite well. You can see that not each key point is kind of equally represented. So, for instance, the most important key point in year 2016 is the key point called "This patient may have had reactive arthritis," followed by fever, otitis media, and baby boy has significant pulmonary hypertension. So this is a view of all of the key points. But obviously, we want to go a little bit deeper and see what each key point is really about. So let's say that we take the most important key point in year 2016, which is "This patient may have had reactive arthritis," and we're interested in seeing what actually is classified within this topic, within this key point, sorry. So the key point is actually named after the most representative sentence in the whole cluster. But as you can see, most of the cluster is still about arthritis, about joints, about muscles, bones, and so on. Not all of them, of course. In machine learning, there's always some room of error. But as you can see, most of the sentences, in a way, relate to arthritis, bones, muscles, as I said. Now, you cannot explore all of the sentences if you have only 25, but if you have 25,000, then it's more complicated. However, this is a very good use case, or a very good situation to use the term wikifier. So what we have done here is we have looked at each of the key points, and we have seen what are the Wikipedia articles that can be related to the sentences that fall within each key point. This means that for the key point, "This patient may have had reactive arthritis," in 2016, there is several mentions to knees, to rheumatoid arthritis, osteoarthritis, pain, and so on. So, in other words, what this means is that, again, the topic is about bones, it's about arthritis, of course, it's about muscles, and so on. But more importantly, with the term wikifier, we are able to get deep meaning for the topic. So if the description, "This patient may have had reactive arthritis," is not enough for us, when taking the term wikifier, we are able to extract all the information coming from the sentences. And in Wikipedia articles, which of course are quite dense and quite deep in terms of knowledge. So in a way, our idea about the key point that we are dealing with is expanded and it's improved. Now, you may think that this is a bit of a research type of use case, but what about public health? How can a population health management expert look at this and extract value from it? So population health management usually deals with trends, with health indicators that happen at the community level, at the regional level, something above the individual. So there are some variables that affect a big group of people that a population health management expert would be interested in. These can vary. So for instance, you would be interested in smoking rate, which is what we are showing here, but you can also be interested in obesity rates or child obesity rates in a region. You can be interested in air pollution. You can be interested in diabetes. So it's these kind of things that have an impact on the society and on a region as a whole. In this particular case, like I said, we have looked at the smoking rates of the boroughs of London, and we have correlated the incidence of smoking rates with the incidence of key points. Now, remember, we are looking at random boroughs in the case of key points, and we're looking at random dates, so these numbers are random. But the idea is that someone that is interested in what's happening on the smoking rates could also find value in the correlating this with key point analysis and seeing maybe trends that they were not aware of, or things that they just didn't occur to them. Now, say that you are interested in why smoking rates are quite high when the topic this patient may have had reactive arthritis is also quite high. So we can go here to these maps and see. So this is a map of the London boroughs, for those of you who are not familiar with the geography of London. And you can see the distribution of these key points in each of the different boroughs, and also of smoking rates. So for instance, you could say that there is a relative high incidence of this key point here in the borough of Newham. And there is also a relative high incidence of smoking rates in Newham. So this already kind of gives you some information that you can find useful. But you may also be interested in seeing what's going on in Newham, now that you have found out that there is both a lot of arthritis and a lot of smoking. So you can go deeper and look into, again, the Wikipedia terms for the borough of Newham. And by doing this, you will know what's happening at the GP level or at the hospital level in that area. What are the concerns of doctors, and what is happening? What are the diseases that people in Newham are having that could be driving smoking rates and also arthritis? So as you can see, in Newham, there's a lot of rotator cuff related problems, obstructive pulmonary disease problems, pain, lumbar pain, chronic pains, and so on. So now we have an idea of what can be happening that is relating arthritis and smoking rates. And with this, I conclude the demo of the presentation. Now, I just want to say thank you to all of you, and well, if you have any questions, it's the time to ask them.
Amazing, Alvaro, Adam, and Yamini. Thank you very much. That was a brilliant session. It's amazing what we can do at data science now. Just watching that has just kind of blown my mind a little bit. It's not really a subject which I get involved in personally, but it's fantastic to see what people are doing with it. Miriam, are you there?
Yes, I am. Somehow my Crowdcast controls are really slow today. Apologies for that. Great. Shall we go through the questions? Yes.
Let's do some Q&A. So we have one in the chat, and I guess this is aimed at all three. Could the Wikify API be used to help patients to understand medical documentation by linking it automatically to verified sources?
That's a good question. I I'd like to understand what verified sources actually means, or what this person means by verified sources. But just to give you a bit more understanding of what the term Wikifier does, it actually just looks for Wikipedia articles. So in a way, it's not that you can link it to other places other than Wikipedia. But having said that, there's many ways in which you can use Project Debater. You can, here we were discovering topics, but maybe what you want to do is discover words within a topic, or you can want to discover, or you have your topics and you just want to see what's what links back to the topic. So in a way, if you're clever of how you define the problem, you can kind of search within those sources that you may be interested in.
Awesome.
Yeah, I think it only looks for Wikipedia concepts and articles, right? So as long as you're looking to search within Wikipedia, it's a very good API. As we also spoke about term relator, so it's a good example. So if you do want to get into details of, say, medical documentation, and you don't, like, so for example, I'm thinking one of the visualizations which says ventricular tachycardia. So the term Wikifier brings up different terms like atrial fibrillation, cardiac muscle, ventricle, heart failure. So sort of tells you what the topic is related to. So it will give you, help you get insight of different topics. But as long as it's limited to, if you're looking within Wikipedia.
Brilliant. Thank you, Yamini. And from the same person, Grace, she's asked, do you or could you also plan to apply it to crop and livestock health to enhance food security? Which is a really cool question.
It actually is. Honestly, we haven't thought about that. But so if you have text data, I'm pretty sure you can.
Fantastic.
And honestly, I would be really excited to see that application. But
I guess with things like this, it's kind of, you can use almost all data, right? That's kind of...
actually, something when you were saying, Liam, that you were mind blown with what data science can do. This is a way of showing actually what data science can do, because we have been speaking with different clients, and they have this data, they have text data, but and in fact, well, there's this myth, but I don't know if it's a myth or a reality, that 80% of the data that is produced in organizations these days is text. So there is a lot of people with a lot of data in their hands in the form of text that they don't know how to use. And in a way, this is the way that you can use it. So this is just to spark some ideas in your mind. So with this food security use case, I'm pretty sure you could do something.
Likewise, data is the new oil. That's what I say anyway. And it's how you use it and what you do with it next is what's really important. I guess that kind of wraps up from the questions. I think, Miriam, is there polls? I think Miriam's Crowdcast is quite slow. Yes, down at the bottom, there is 2 polls. Yep. So if you want to have a look at those, answer the questions, that'd be really helpful for the speakers. Do you want to explain a little bit what you're doing with that, or is that just to gain some insight from who's turned up?
Yeah,
oh. Go ahead.
No, it's just really to have an insight of what people are familiar with, what they have been doing. So it's mostly for us, to know.
Yeah, fantastic. If you want to answer those questions, really good to know what everyone's thinking. Because like me, I'm joined in. I'm a host. I do this so I can get insight into all these different areas of technology. It's fantastic to listen to and sort of see what's going on. And for those who are wondering, yes, this is recorded. So Yamini, you might want to change your API key. This is available afterwards as well. And you can all follow along with the lab through Jupyter Notebooks. I believe it's on GitHub. You sort of follow it through, load it into IBM Cloud, and you can follow it through there. And Jupyter Notebooks, I think, do you want to explain what Jupyter Notebooks is? Because I know you guys had it all sort of filled out.
Yeah, I think you want me to explain. So all of the instructions, of course, are in the GitHub repo, right? So I understand there was a question about what happens after, but it was literally once you load it, we were hoping you can follow along with us on the session as we walk through each of these cells. So if you do want to do that, you can go back to the recording and, walk with us during the session. But there is enough information to actually walk through the notebook itself. It's pretty self-explanatory. There are a lot of comments and links that have been also mentioned within the notebook. So yeah, you can work through it yourself. If you do have any questions, I think there are links on in chat. You can reach out to us via email or LinkedIn. You can also get in touch with the debater team if you have specific use cases, as you would know, some of you had specific use cases. So if you do want to get more insight about from the actual team itself, the research team who worked on Project Debater, you can find their details as well on the Early Access Program website. So you can get in touch with them or with us, and we connect you to them if needed. And yeah, reach out to us in case of any questions.
Awesome. I guess that wraps up this session. That was fantastic. Thank you very much, you three.
Thanks a lot.
Thank you. Thanks, Liam. Thanks, Miriam.
Thank you.
Thanks, everyone.
Thanks
Thank you.
very much.
Thanks, mate.
And with that being said, I am also going to dive out for a little bit. I'm going to go have some lunch, and taking over my spot, we have got Tel. Hey, Tel.
Hey, how are you guys? Nice to meet you, everyone.
Hi.
Our next speaker is here. Olaf is here. You want to continue?
Not just yet. Bye,
Yeah.
Liam. Thanks, Liam. I'll just share the Crowdcast was saying there are too many people to share my screen. So I'll just share the schedule for today. So we're in 2 sessions. We've had them already. And yes, Olaf, I'll invite him to the screen.
Yeah. So before invite Olaf, and I will explain and welcome everybody. So thank you, Miriam. Thank you, everyone that was before. I will be your host for the next 2 hours. My name is Tal Ne'eman. I'm a developer advocate, also based in Israel, and a chronic early adopter of new technologies. My professional engineering background is mostly around cloud technology, mobile development, and some other container open source related technology out there. So it's not about me today, of course, but we have a great session ahead of us. So I hope you are still enjoying our sessions, the 2 previous sessions that we had, and the whole day of the Developer Festival here. Please tell us in the chat if you have any questions. How is it going? Where are you coming from? And everything you'd like to know, we would like to communicate with you. So feel free. Don't be shy. And I'm very excited to be part of the festival, of course. So thank you all. And as you already saw today, it's not all about open source, AI, and machine learning. And we have still 3 more sessions for you. So we have a few things to come. I think Olaf will be with us in a few minutes.
Yes, I'm just trying to invite him onto the screen.
That's totally fine.
Well, while I do, yeah, perhaps the last session today is about data, AI, and automation, and that's on a different live stream link.
Yeah.
So I'll post that in the chat.
I will talk about this at the end of the session, the last
Yes.
session that we have. I will talk about this. Of course, I'll tell everyone where they need to click and where they need to go to the further session, so don't worry about it. And I will explain. I will wait for Olaf because I want him to be here before when I talk about his session. If it's
Yes,
okay.
he's just joining now.
Oh, great. Here is Olaf. Hey, Olaf, how are you?
Hi, I'm good. How are you?
Okay, take a minute. I will introduce your session, and of course you, and then you will start your session. So, as we said, our next session is about building and scoring Python models with Olaf Depper. You will learn how you can accelerate application development using machine learning and artificial intelligence. You will see how to build score Python models in data warehouses. So stay tuned for the live demo of Olaf. And a little word about Olaf. I'm sure he will introduce himself, but I will do it briefly. Olaf is technical specialist in the IBM technology team. He's worked in a variety of consulting, software support, and technical sales roles. He is a seasoned speaker, already presented at conferences around the world. And I'm really glad that you are joining us today to speak about Python models, Olaf. So the stage is yours. Share your screen and go ahead. Have fun.
Thanks, Tal. So first challenge will be, of course, using this tool.
Don't worry.
I tested the first time on Friday, so I hope I didn't forget how it works.
Okay. So is your screen great?
Okay. Yeah, so thanks for the introduction. And as Tal said, my name is Olaf Depper. I'm here out of Frankfurt, Germany, enjoying the lovely weather that we have today. I hope you guys have better weather. So my background is actually I'm a database guy. So I'm coming from a database DBA system administration background, and in the last years mostly concentrating on the data warehousing side in IBM. Namely the Netezza performance server and also DB2 warehouse. As you can see, you can find my email address. So if there's any question afterwards, just send me an email. Also, you can find me on LinkedIn very easily. So there's only one Olaf Depper out there. So if you want to, just connect. So what I'm going to talk about today is building and scoring Python models, especially concentrating also a little bit on the where do I get the data from, because it's not only that you need the Python skills, but you also need to be I mean you need data to work with, right? And the question is, where do you get the data from? And I want to show you one way to get the data, which of course, I mean, data science, the whole machine learning is a wide field, but this is one thing that you might be able to use either in your company, or if you're a student or so, you can use a developer edition as well. So as I said, I'm going a little bit about Python models. What Python models? What is a typical workflow, basically? How you can access data? Where you get this data from? And then again, in this example that I want to show you, is a new possibility where instead of getting data like exported from a database or from a CSV file or wherever your data might reside, but instead use in database analytics based on this example on the IBM Netezza server. So I'm going to talk a little bit also about Netezza, and then I'm going to show you a demo, which, to be honest, at the moment or before this call, I had some issues getting it to run, but let's see, maybe live is better than the pre-live. So scoring and building Python models, there is a workflow. I mean, depending on how you do it, but it's usually always the first workflow. Now there's a similar workflow. Obviously, you start with defining what you actually want to achieve. So what is the use case for your machine learning? So the typical use case that you see often used by IBM and also by other folks is, for example, customer churn. So you want to basically see what's a bad customer, what's a good client, good customer. So which client will most likely stay with your company, or which client might choose to go somewhere else. Another one, very important, but that you have seen every time you use a credit card, basically something like fraud detection. Like if is the current use of your credit card a good one, or is it maybe has been stolen, with identity, stuff like this. So this is the typical use case. And again, what we are doing here is just an idea. So what I'm going to show you is a stock prediction, which obviously only works to a certain amount, because if this model would work perfectly, I would be a millionaire not working anymore, because obviously when you can do stock prediction perfectly, you know what the stock price would be tomorrow. But you get an idea of what I'm talking about. So this is the first thing, of course, define the goals. Then you need data. Again, either historical data, or you take a split of production data or CSV or whatever, perform some data cleaning, so prepare the data basically, and then you start building the data and building the model in Python. So this is usually the first step where you actually start working with typical libraries like Panda and Scikit, NumPy, and so on. And then you do score the model. The other word for scoring is basically you're creating predictions. So basically, you build a model, so you have a hypothesis how this might work, and then with scoring, you use current data or other data to see if this model actually works the way that you think it works. And then depending on your scoring, you evaluate it, and hopefully the model looks good, so you can deploy the model in production. So these are usually the steps of building and storing Python models. And again, outside IBM, there are a plethora of tools available. Inside IBM, what you would use is the Watson Studio with the Jupyter notebooks, basically to build the model, and then the Watson Machine Learning to run the models. Both these Watson Studio and Watson Machine Learning, of course, there's enterprise editions, but if you're really interested, just get an IBM Cloud account, which you hopefully already have, and give it a try. So there are free versions available for both of them. A great way to really get the feeling for these tools. Another really cool and also very important tool, which I'm not going to show, is this Watson OpenScale. Watson OpenScale helps you to look at the model and remove any bias, for example. So we all know there has been enough cases where machine learning models were not taking into account certain groups of the population, for example. And with Watson OpenScale, really the idea is to get a fair and explainable machine learning model, which I think is a super important topic, but again, outside the scope of today. So very important, similar to the bias that I just talked about, is like a model can only be as good as the data you're using. So a common sentence you read there is garbage in, garbage out. So basically, if the data is not good from the beginning, your model will most likely be also not valid or incomplete. So this is why it's so important to get good data to build models, and this is where I think data warehouses or databases play a critical role, because in the end, where is data usually stored? At least in a company, hopefully not in a CSV file in Excel or so, but somewhere in a database. So databases are usually, hopefully, the base for the data on which these data models are built. So ideally, and this is what I'm going to show you, is that you can run these Python models directly in the database, so with so-called in-database analytics. Why do I say ideally? First, you have the convenience that you don't have to move the data. So the data sits where it already is. So you don't have to do a deal with all the things, moving data somewhere, storing it. And very important these days, especially in Europe with GDPR, is like compliance of who can see the data, what's in there and stuff like this. So this is the one thing. The other thing is that usually when you run your notebook on your machine, you might have a ThinkPad, a powerful ThinkPad, or one of these nice MacBooks they just introduced yesterday. But again, it's a PC. Whereas a data warehouse, you might have a parallel systems on MPP environment where you have really lots of servers basically running in parallel, working on getting you the data, running the analytics. And this is exactly the idea why I say in database analytics is very good and might be for many use cases the ideal use case. So again, databases, data warehouses, they come with often with inbuilt analytics. It's, for example, DB2 Warehouse has machine learning functions. Other vendors have the same thing. In IBM Netezza, we have also these so-called INSAR functions, which are out there for many years. And then this year, we have this new Python library, NZPI IDA. So that's this one, NZPI IDA. It has been renamed, it was named differently originally, but now this is the name. You can see you can just install it with pip install, so it's part of the Python project. maintained by IBM. And this really allows us to run Python functions directly against the database. So no need to get data first exported from the database, put it somewhere, and so on. So again, the advantage is, as I just mentioned, compliance, speed, space, and so on. So 3 words on Netezza, which probably most of you guys have never seen. So with Netezza, we are talking about a data warehouse. Originally was an appliance, now it's available as in the cloud as well. And it's super fast and it's super simple. So it's really, as you can see, it can scale. It is simple, it is fast, so you don't need to do lots of administration. So if your organization, assuming you work in a company, is looking for a warehouse performance server, contact me is a nice, or maybe the best solution. Again, if you're more in academics or so, what you can use, and you're interested in Netezza, there is a developer edition out there, which is basically a single, so you don't get the parallelism, but it's you have the engine, and you can work with Netezza on a single node file running Oracle VirtualBox, so basically a VMware. So how would such in database analytics with Netezza look like, assuming you're going this route? So first thing is probably you fetch a small data set from Netezza to your client, and again I'm talking a small one, so that you can start building model, do data exploration, like look how the data looks like, whatever you need to do. So this is basically you're preparing and building the model. And then once you are fine with the model, you would then execute the model not on your local machine or not on a whatever machine, but you would push the analytics to Netezza. And why is this good? As you can see here, this is like the kind of a very small overview of Netezza. So what you see here, these little pieces, these would be the different spoofs, as we call them in Netezza. So these are snipping processes units or partitions in other databases. So this is really when you have a database table, usually split across all these spoofs. So when you push analytics or run analytics, all these spoofs would run in parallel. So this gives you really the advantage of using the MPP of the host instead of running it maybe on a single notebook. So this is really the idea behind this. So again, you're running the model on Netezza, and then you fetch whatever the model provides as predictions and visualize it on Cognos or Tableau or whatever the GUI of your choice might be. As I said, I mean, this is not a Netezza presentation, but if you're interested, there is a Netezza developer edition available. Just search for NPSVB, and you can download it. As I said, it's based on Oracle VirtualBox. As I said, why is it important? So our development did some tests, and again, as always in these cases, your mileage may vary. So what you have in your environment, of course, might be different. But what we have seen here is we were running a weather prediction. So we are building a model, how will be the weather the next day, based on a Kaggle data set for Australia, split across 48 partitions or locations. And then you can see the data set size, so 100K rows. If you run it locally, basically on your local machine, it was 240 seconds. On Netezza, using all the parallelism, it was 6 seconds. And of course, the larger the data sets growing, the better, or the more you will see the MPP use cases. So this is the 1.5 million data set size, and you can see it's super fast. It's 30 seconds, so half a minute on Netezza, and it's I don't know how many minutes, over 2,000 seconds on the notebook server. So this really shows that for some data sets, obviously not for all data sets. So if you have a small data set, running it locally might be the better approach. But the larger the data set, which also probably means the better the data model. Try to use something like in database analytics, because again, this will just give you the not only the speed, but all the other features that the database provides you. So now for the demo itself. So as I said, what I'm trying to do, and at least as I said before, I was having some issues to get it running on my Netezza Fire instance. So I have a developer edition. I also tried the cloud instance that I have access to, but we will see how far I get. But again, what I'm going to show you is building a model based on stock price prediction. So the idea is that looking at a certain stock price, for example, for the Tesla stock, can you do a prediction on how the stock price will be in the future, so tomorrow, basically. The NZPI IDA library, that's the one, again, that I'm going to use to get the data. This has different APIs, which some of them I will use. So this is this NZ-Fun apply. So it's applying a function on each row. Fun T apply is a function on the entire table, and grouped apply is on subsets of data, which is usually the probably the most common use case, I would assume. And then I'm going to use Watson Studio. I'm also showing it through Jupyter. So if you're not in Watson Studio, Jupyter will be of course the same. And Watson Studio is basically the Python notebooks that I'm going to use. And again, inside there you would run all the steps of building and scoring in the model. And then we also have the Watson machine learning, where you would basically deploy and run the model. So once you have decided on the model, you would then, of course, at one point run it, because it's not only that a data scientist creates a model and is happy, but at one point it needs to be put into production. And for this, for example, you would use the Watson machine learning. Some of the libraries, and again, I'm not the Python expert, but these are the libraries that usually are used. So probably most of you who have seen or worked with Python before, you will know them. One thing that you might not have seen here is the Watson machine learning, which is the IBM machine learning libraries, which is also, of course, a Python library. So let's see. Okay. So there are also two polls open. I'm not really sure I mean, you can basically enter them, anyone. So this is the question is regarding Python, and also what is your favorite interface. Another thing is, which you can probably answer through the chat, if you have seen and worked with Netezza before. So if you can just put something in the chat, I'm just out of curiosity how you would, or if you have seen Netezza before.
Yeah.
And again, it's a really nice database platform.
Yeah, I will ask Miriam to do it. And of course, we have one question before you start the demo. If you want to answer the questions, someone asked about what are the performance impacts of database analytics in database analytics.
Yeah, that's actually a very good question. So what is the impact? Of course, it's an additional query running on the machine. So it's ideally the machine will handle it if your machine is already on any database is already on a very high usage factor. This is something you might want to use. In talking in Netezza speech, we have something like a workload management, basically, which usually should take care of, or you can take care of, on how much resources such a query can use on the database.
Great, thank you.
Thanks. So as I said, we have So what I'm doing, or trying to do at least, is the using Watson Studio connecting to Netezza. So this is, for those who have never seen it, so this is my IBM Cloud account. You can see this is my private account, so it's not an IBM sponsored account, so it's really like how your account would look like. And then you go to services, resources, and then you would basically deploy a Watson Studio. And the Watson Studio, which I was just go to get started, and then it would deploy the service instance for you. And then you are in Cloud Pak for Data. So this is the next screen that is created, and then you can see that you will have different projects, and these projects you can have data assets, so you can basically connect to a database or to a CSV file or whatever, and use them. And you can also see that we have our notebooks here. So these notebooks, this is what you would know from a Jupyter notebook. And I'm just going to show you this one here. Sorry for finding the right screen. Okay, so this is the as I said, the Watson Studio, and then we have the model building notebook. So this is one model building notebook, and again, I mean, I've seen just in the polls that at least some of you have worked with it. So this is how a Jupyter notebook in Watson Studio would look like. Again, if you have seen Jupyter notebooks or Jupyter Labs or PyCharm before, you know it's a similar output. So you can put stuff in quotes, basically comments, and you can have run pip commands and so on and so on. So the first thing here is, and what I'm now actually running is I'm running, so I have my notebook, and this notebook is running now a really small VM in IBM Cloud. So this is basically a Python environment, which you can see, and you can again get this also. I mean, of course, the larger the machines, they are limited, but you can see on a small 1 CPU, 4 GB RAM environment. So this is the environment in which my notebook will be running now. And the first thing is now that I'm going to install my NZ-PI IDE. And again, this is the library from Python for connecting to NZ, which is short for Netezza. So this should actually give me just an already satisfied. You can see because it's already installed. So once you have installed it and the Netezza or the instance well, the VM is up and running, this will be, of course, will be still active. So no need to install it all the time. Then the next thing is we are importing some libraries or some packages, and as you can see, this is, as I mentioned, Pandas, which is one of the most common Python libraries for accessing data, basically. And then we also access the NZ-PI IDE. So again, this is our library from for Netezza, and in here we are importing certain functions of this library. For example, this data frame, this grouped apply. So this is the function that I just mentioned, which accesses data sets inside Netezza. This is this NZ fun grouped apply. And then from the machine learning from IBM, we are importing another function. And then let me just run this. So this is, I mean, it's not doing anything, so it's pretty quick. So the first thing now where we actually access Netezza, this is now this piece. So, and of course, I'm going to change the password afterwards, so don't try, but at the moment, this is the user password connecting to, in this case, a Netezza environment. 5480 is always the port used by Netezza, and stocks, this is the database we are using, and also the name of the table. And then you see this IDA-DF head. So the IDA-DF, this is the data frame function of the NZ library, which allows us to look at data. So we remember the steps of building a model. So the first step here is basically we are looking at the data to get an idea. Okay, what does the data look like? Because as I said, I mean, you will have an idea. For example, you want to build a model based on or predicting stocks. So the first thing you want to basically look at is, so for example, how does the current data look like? So is the stocks data table the one that I need or not? So this is why we have this here, and you can see with head I'm looking at the first 5 columns of this table, and you can see the first 5 rows, of course, and then you can see the different columns. Thus, there are some more functions available. For example, IDA DF shape, which basically tells me, okay, how many rows, how many columns. So you can see it's not really a large table, but this is basically provides me with the opening cost, like which stock price was at the opening, which stock price when it was closed, what's the high, what's the low, what's the volumes, how much was dealt with, and then the different price. So this is really the very basic idea to get the, first of all, we are getting the NZPI IDA installed. So this is the first step. And the next step is we are actually using this to connect to the database and get an idea of the data itself that is already in the database. Another thing is when you are running Netezza libraries, and you're running them against the database, the most common ones like Pandas, and so they will be already pre-installed on Netezza. So there's no need for you to install them on Netezza itself. So this is another thing. Then we have Watson machine learning. Again, Watson machine learning, what you can use here is once you have built a model, you can basically deploy the model. And this is what we use Watson machine learning for. What you need here, and this is all based in the IBM cloud. So what I'm going to do here, and this is again more like of an informational or prep step, this is like looking into which deployment spaces do I currently have. So a deployment space, that's basically this space in Watson machine learning, where I would then put the model to run it in production, for example. And then I can also show me get a list of the models that I'm using in these deployment spaces. And this is then, for example, the type of Scikit learning, for example. So this is again, it's more of an informative space. So this is the building. Again, we are starting, or we have an idea. So we have our stocks table. We have we know what it is. So the next thing is then I'm going to this. Again, this is the same starting point. But again, I'm trying to maybe show you this one. So the first thing here is, again, this is now on Jupyter Notebook, and you can see this is the same idea. You get some warnings because some stuff is deprecated, but other than that, it's the same idea. So I have my same table, and I can connect. And again, I mean, this is the charm of Jupyter, that you can of Python, that you can run it in the basically on every environment. And again, this is now the first step here, and this is what we are going to do. Is we know the data that we are looking at. So we are looking into stocks. What we need for the stocks, since this is a database table, we would need some kind of additional column, as you want to say. So we want to improve or we want to get additional information, because at the end we want to we want to have a prediction, which at the moment, of course, it's not part of the table. So what we would do here is we are taking the table, and then with this table stocks, we are creating a new table which is called stocks, which is the same data, but it will have an additional field which would be the future close price. So the future close price would be what we are trying to create as the basically prediction of our model. So again, this is Jupyter. Let me switch back to my Watson Studio. So no, this is not the one. That's the one. So with this one is again, this is Watson Studio. It's the same idea. So what we do here, again, we are loading our packages. We are creating this basically this copy. We are saying, okay, how many future days do we want? And then we are putting this as the future close price. So we are doing basically this function that I just mentioned. We are adding this future close price. And then we have this moving average indicator. So we can do basically a future prediction on how this will work. And then we are doing some functions basically around changing float values and so on. So numeric values have to be adapted, missing values have to be adapted, and so on. And then we are basically doing a training on this. And again, the function that we use here is this fun grouped apply. So this is the one again that is running against the whole or not the whole. Fun grouped apply is against parts of the database table, so not against the whole table, but what you usually would use with a select statement and stuff like this. So let's see if this works. And again, before this, I was having issues, but let's be optimistic. So this is now creating these, instantiating this runtime. And again, the runtime has been created. This is now the PIIE. So again, this is our package, which should be already in there. And that's, sorry, my keyboard. Oh, sorry for that. That's a problem if you don't properly name your packages. And you see there's now some warning, but again, this is just information. So this is really nothing serious. So let's try if this works. Okay, it's not working. So you can see this is now trying to connect to my to Netezza, because if you've seen, I was using the wrong information, so it didn't work. I can run this shape again. So we have already seen this. So let's now try this piece. And again, that's the one that was failing before. Okay. Yeah, I think something is wrong on the database. So, as I said, there is the Netezza functions, and I think they are currently not properly cataloged on this instance. So this is again a cloud instance. So let's again, sorry for the but this is how demos work these days, right? Sometimes it's not working perfectly. But again, go back to the Jupyter. It's the same idea. What we are doing here again is we are creating the copy of the table. So we have created now basically a table that has the predicted value, and then a very common feature in this Python model building is you are splitting the data. So you're doing a split table basically, which common here is we are using 90% for the training and 10% for testing. So again, we are importing our NZ libraries. We are running again this function group apply. So these here again, this is working with the data itself. And this is then the name of the table that we want to create. We also can drop it if it already exists. And then we are running this model here to basically use 90%. And again, this is this time. This is the data percent 90% of the for the training data, and this would then create the table. And again, I'm pretty sure that this is now not working again. Yeah, so sorry for this feature. But again, it's not really sure what happens, but it has to be something with the INSA libraries not probably working at the moment. But hopefully, again, you get an idea. So what we have done now, so we have looked at the data, we have added this column, we have split it into this 90-10% rows, and now we are working on this data. And again, this is the test data. So we are running our training against this test data, and then we have an output. And again, we are using the group apply to put the output into the this table. So we are using the index ticker, which is the column, and we are using the functions stock test data, which we have defined before. And based on this, we are now basically trying to build we are training the data, and we are trying to basically create this new data. And this is now our training data. So you can see this new column, future close price. So this is basically what we assume what the close price on this day would be. So this is this new column filled out of the model into this new table. The next step, and again, because we are using IBM Watson machine learning, the first thing is we would delete. You can see the machine models that I showed you before. So we would clean up if necessary. So you can use Watson machine learning to delete values. So this is basically this one. And then once we have cleaned up our machine learning, we are now running the model building itself. So this is this code here. So what we are basically doing here is we are using Scikit function to do the estimate. So we are looking at the training data. Based on this training data, we put this into Watson machine learning. So this would be here. And again, this is just a demo because at the very top it doesn't work. So here I would need to put my Watson machine learning things. And then in Watson machine learning, I would basically save the model, and then I could reuse it all the time. So this is in here. And again, so the whole Python logic behind this. So this comes from a colleague from development who developed it. And you can also get it from the IBM Netezza developer side. So the idea is, you can see we have this random forest regressor, and this is where we are calculating basically the future close price. Again, do a prediction based on what we assume that the next stock price would be, and then we would again calculate this based on the ticker. So these are the models we are using. Again, this is scikit-learning and Watson machine learning, and these are the different tickers that we use. So ticker, again, this is the Tesla, IBM, CVS, so the different stock tickers on Dow Jones or wherever this data comes from. And then we retrieve the models. So we have now built the models, stored them in Watson machine learning, and now we are taking the model from Watson machine learning and basically score it, so run it on Netezza. And this is what we are doing here. So again, we are taking our test table. We are then importing again certain functions, and then we are running it against, we are running it against Netezza. So again, we are connecting towards the machine learning to get the model, and then somewhere down here we see our basically running it against the database itself, and then putting the output into a table again through this Netezza functions. And again, the output then would be something like this. So we have a prediction, future close price prediction. And then again, now I have to switch to, because there's also it builds some graphical interfaces, which I just have to find. And again, sorry for the demo not really being online. That was not what I intended to do, but that's the way life is sometimes. Where is it? So this is how it looks like. So this is now basically what we did. So we looked at the table. We saw, okay, the table we need or we want to predict. So we added this basically training table. We splitted the training table. We built a model. We deployed it on Watson machine learning, and now we are running against Netezza. And again, with Netezza, we have the advantage that we can run it within all the slices. So we are running it on the Netezza host and also the spoo. So again, the Netezza snipping units or partitions. And then we do, this is what I meant at the end, you can basically do a graphical plots or charts or whatever you want to see. And what you will see here, for example, if you look at the IBM stock, so this is the IBM stock. So this is what we are predicting, and this is the price that was the real close price. So you can see the prediction is kind of, as I said, it will not be perfect, because if somebody would have the perfect model to build or to predict stock prices, this person would be rather rich. But it gives you an idea where you can get by using the all stocks price and build this model to get an idea on how this works. For example, Tesla, I think nobody predicted Tesla, right? So this is why the future close price of Tesla, and this is our prediction. But for some of them, you see it's actually pretty accurate. And then at the end, I would do something like result head. So this is the same without the as a table interface. So this would give me, for example, the accuracy. As you can see, it's not great. So there are probably use case or models where the accuracy will be much better. But again, stock prices is it's kind of more volatile. But I think it's a nice idea, because it gives you an idea on what you can do. So as I said, this stock price is not, or the whole idea is, if you're really interested in it, it's just like NZ, search Google for NZ PIIDA, and then you can go to, that's not the one, it should bring me there. So this is in developer.ibm.com, which you're hopefully all aware that this site exists. And then you can get the same info, or then you get the information. And again, if you download the Netezza emulator, you can run it on the Netezza environment, and this gives you an idea of basically what the table looks like. You can also download the table information here. So really give it a try, play with it, and let me know how it worked on your environment. So let me find my.
You have anything else I have to do?
No, I'm fine trying to find my. Trying to find this one. Okay. So I said first time I'm using Crowdcast. So
No, it's okay. It's okay. You did definitely did it well, and thank you very much for your session. I see we still have some time, so if anyone has some questions, you already can give them in the chat. If you have any questions to Olaf, you bring us a link to the link to show us right now. The link to the developer.ibm.com that you showed. So
I just put it in the chat, right?
Yeah. Just write it down, and you have it. So you can use this link to do the guide, the workshop that Olaf just did. And we had one question we answered during the session, so this was great. I think we will take like a few minutes break because we have time to the next session, so it's okay.
Yep. So if
I will ask Miriam to come over and start the next session. So thank you very much, Olaf. If you need Olaf, you can find him on LinkedIn. You can connect to him. We'll be able to answer your questions, of course. Hey, Miriam, how are you? You're on mute.
Yeah, somehow Crowdcast is taking its time to unmute today.
Yeah, we did have one question. Olaf, you're still there, great. A question on Twitch, which was, is Netezza restricted to... Is Netezza restricted to a fixed set of models and metrics, or can you provide your own algorithms and scoring to run elsewhere? But maybe you answered that already.
There is. I think the question is regarding like what kind of libraries can I use on Netezza. So there is that's the one caveat that we have, that there is basically, because it has to be deployed somewhere. So there are, especially in the cloud, there are predefined libraries which are also pre-installed. So these are there. If you have and I mean in Python there are 1 gazillion of different libraries, and if you have something which is not in there, that's something we probably need to discuss if this can be put on Netezza or not. But to answer the original question, yes, there is some restrictions based on what's available and whatnot.
Okay, super. Thanks for that. And I did post the links over in Twitch as well. Great. Yeah, thank you very much. Really, really interesting session.
Okay. Thanks, guys. Thanks for your.
Thank you. Bye-bye.
Thanks for listening.
See you again soon. Bye.
I think we have still a few more minutes before our next session, right? Or they're here already?
Yeah, we do have a couple of minutes before the next session. Yeah, we can take a quick break.
Okay. So guys, thank you for staying. We are taking a few minutes break till our next session. So we'll be back like in 5 or 10 minutes. So hope to see you here with us. Thank you very much. And if you want Miriam just to share the screen, the slide that give the agenda, it will be great. I know it takes some time. It's okay.
Yeah, it's loading right now. Maybe, yeah, there we go.
We see. So thank you, and we'll see you all in 10 minutes. Thank you very much.
Thanks.
Hey, George and Javier, how are you guys?
Hi, Tal. How are you?
We'll start in 1 minute.
1
We will
minute.
start.
Are we live already?
What?
Are we live already?
Yeah, we are live, of course.
Okay.
We waited because the previous session ended a little bit early than it should. So we said that we have a 10-minute break, so everyone is waiting, and it's okay because we have still 1 minute. And of course, we will introduce you. And I see that Miriam just dropped off because probably she has some internet connection issues. So I will wait 1 more minute, and then if she is not here, I will introduce you guys, and we can get started right away. So still we have 1 minute, and we start.
Let's finish the break.
Excellent. Very good.
Hi, Miriam.
Hi, Miriam.
You're on mute.
Yes, it's being very slow today. Sorry, I must have lost connection in between. So I've missed a couple of seconds. Shall I just quickly do an introduction to Crowdcast?
Yeah, go ahead if you like.
Super. So there's some new people joining the stream, so a big welcome to you. I've got just a little bit of housekeeping. It won't take very long at all. If you're new to Crowdcast, welcome. This is very exciting that you're joining us. And you can see, hopefully this is what your screen looks like. It might be different if you're on a mobile or a different device. On the right, you've got the chat, and there people are telling us where they're joining us from. You can chat to us there. Feel free. And if you've got a question for our speakers today, Georges-Henri and Xavier, then please do put a question in the Ask a Question part right at the bottom of your screen. There's a green button too there where you can sign up or sign in for the Code Labs. And if you'd like to stay up to date with all of our events, you can hit the follow button in the top right of your screen. So,
Thank you very much, Miriam.
Yeah.
So I will do the session today, next session. So our next talk is from our colleagues, Georges-Henri Moore and Javier Rey Robert. Together, they will be sharing about ethics and artificial intelligence. It's a very hot topic, as you may know, or read or heard from the news, how AI make biased decisions. So you will see today how we can become aware as a human of these errors, and of course, how we can help people, organization, how we can adopt AI responsibly. So, and of course, beyond compliance and everything. And Georges-Henri and Javier are developer advocates on our team in France. Georges-Henri is a data scientist and master inventor with a PhD in data and AI, and was worked with various companies and universities on both sides of the Atlantic. So this is really cool. Javier is an IT architect with deep dev skills. He has an experience in a variety of industries as well. As an advocate, he conducts educate sessions and workshops, also collaborating with the strategic business partner that we have. So thank you guys. Look, that there are a lot of experience with both of you, and I hope to have a great session and hear about this topic as well. So you can share your screen, and the stage is yours. Thank you very much.
Thank you very much, Tal. Xavier, we cannot hear you.
Yeah, we cannot hear you. Yeah.
Okay, now it should be better.
Excellent.
Nice mic, but with a turn off button on it. So just, good afternoon, everyone, and thank you for joining myself and Georges-Henri for this session on AI ethic. Georges-Henri, I was just saying before, if you can relay the questions that we could have in the chat, because I'm not looking at the chat at the same time I'm sharing my screen.
Will do. Okay,
thank you. So AI ethic, a major stake. So let me start with a short movie. Okay, so AI, as Tal said, is a hot topic, and it describes all the moral behavior of humans as they design, make, use, and treat artificial intelligence systems. So this is the definition from Wikipedia. There are a lot of information you can find on ethic, and of course, it's the fact that it applies to AI is not new. We've been talking about ethic in technology at wide for many years. But what is new is that really AI is really exploding, has been exploding in the last 10 years. AI is everywhere, and the way developers company relies on AI is also really specific. So we need to have some principles to make sure that AI and the way it develops is in line with the values promoted by our different societies at different levels. So what is new is the way that these kind of algorithms are actually not programmed. Okay, so this algorithm before, I mean, people were responsible for the algorithm they were coding. It was rather easy to explain how they were working and to find bugs in them, but the new complexity associated with machine learning, deep learning algorithms on which AI is relying very heavily is really staggering. Okay, so this new complexity implies that we need new tools to actually deal with the complexity, to be able to explain what this AI is doing. Okay, so IBM has been really involved in actually defining a set of principles guiding the way we as a company are actually implementing AI. As soon as in 2015, Francesca Rossi was actually appointed the global AI ethic leader. That was soon after we created the Watson division in charge of everything related with the AI in IBM. So Francesca has been taking a leading role into really defining this ethic principle in IBM, and also trying to change the IBM culture, or to infuse these principles into the IBM culture from the top to the bottom with all IBMers. So AI is already used in a lot of applications in a lot of different domains. In banking, okay, banks are relying on AI to assess risk when they are giving loans or these kind of things. Employments, we see AI systems used to screen employees when they apply for a job. The same for admissions to education. Big university are using that. That's the case in France, where we have an AI systems actually trying to route the different students applying to the different schools. In healthcare, in a lot of different kind of enterprise workflows. So AI is everywhere. So that's a different kind of definition that I had, but a little bit more complex. And that's actually the view that is promoted by IBM. To really understand how to optimize a technology beneficial impact while reducing the risks. And that's what we are trying to achieve with AI while prioritizing the human agency and well-being. Okay, so that's an interesting paper that is available. That's a study that was actually, or a point of view that was actually done by the World Economic Forum, studying the way IBM approaches ethics. So responsible use of technology, the IBM case study. The company has worked to develop a culture which thinks of the ethical impact of its technology and how to steer technologies toward their best use. So what it means, and this is another paper that you can find, Advancing AI Ethics Beyond Compliance, that's a PDF. But what it means that we defined a set of guiding principles that we are following in IBM. So first, the purpose of AI is to augment intelligence, human intelligence, and not to replace it. So this is kind of, it looks like a really simple principle, but there is a lot behind it, because it's also if the human intelligence is still in charge, it's also the human that is actually accountable and responsible for what he is doing with AI and the consequences of AI. Okay, so it means also that companies, governments should not be able to hide behind the technology to say, okay, it's not me, it's Mr. Tin Can Head here over here is responsible of the decision. The AI is responsible. No, it's really the human that is augmented and the human intelligence that is augmented, and we should take responsibility of what the technology is doing. Technology must be transparent and explainable. I will come back to that. And data insights belong to their creator. Okay, so what does it mean? Technology but be transparent and explainable. It means that for the public to trust artificial intelligence, it must be transparent, and technology companies must be very clear about how they train their AI system, what is the data they're using, what is the purpose of the system, the spirit guiding the algorithm recommendation. Okay, so as the AI is actually making decisions that have a profound and impact on our lives, they should be transparent and explainable. So transparency, it's easy. I mean, it's the way that someone would claim how it's using the technology, what is the data that is fed into the models and this kind of thing. So you can be transparent about your goals. Explainability, given the complexity of the AI system, is harder. And to be able to explain the result achieved by a deep learning system is really a challenge to the human mind. So it means that we also need to have some kind of tooling to be able to inspect, understand the decision taken by the algorithms. And this is something that Georges-Henri will come back. I mean, the practical tooling that you get access to if you need to explain the decision of AI. Data and insight belong to their creator is really a principle that IBM has been standing for a long time. It really means that IBM is not interested in and will not allow data of its own customers to be used for other things than their customers' interest. Okay, so we are not going to, as IBM, to use the data to create to get insight on this data and to create new business models or new businesses on top of the data. The data is an insight related to the data belong to the creator, and in this case, the IBM customers. You will see that there is also another pillar that is also really important, that is not directly related, but related to that. It's a privacy. Okay, so data and insight belong to the customers of IBM, but they might have some privacy principle to respect also while actually using the data they are using. Okay, so after the three principle, let's say the three main principles, we have also a number of pillars that are related to the principle: explainability, fairness, robustness, transparency, and privacy. Okay, so let me just find back my. Oops. Just a second, I messed with my nose. Here we go. Okay, so I went through explainability quite a lot, so I'll go on the next ones. Fairness. Okay, as we are relying on a lot of data, and the data that is actually coming from a lot of different systems, we need to ensure that all groups in this data are actually treated with the same equity, the same fairness. There could be some bias in data that would bring some prejudice to some group of people in terms of ethnicity, in terms of gender, in terms of age. Okay, there are a lot of people that could be discriminated based on data. So data could be biased because of bias that are actually existing in the society. So ensuring fairness is also, with the right tooling, is also a way to identify the different bias and inequities that are relying on the data, and there are a lot of different ways to actually solve these biases or help mitigate them. So Georges-Henri will come back a lot on these fairness issues. Robustness. So AI should be robust. What does it mean? It means that it shouldn't be prone to fail because the data, the input data is unusual. It shouldn't be prone to attacked by hackers. Okay, so we all seen these AI systems being fooled when you present to them a specific picture or a specific tag. In the news lately, I mean, some Tesla cars were actually fooled by tags printed on the road into changing lines. Okay, so that's something that. And that's a dramatic case, of course, but that's something we should take care of. I mean, implementing robustness into the algorithms we are training. Transparency, I mentioned that already. To be able to be transparent about the data that we're using, the purpose of the systems, and to be able to comply with the regulations. Okay, and privacy. We should also respect people to privacy and make sure that we handle their data with care and try to anonymize the data as much as we can. Okay, so of course here we are going very far because we want to very fast. I mean, because we want to spend more on the actual technical aspects of the ethic. So, and that's the last slide for me. So we went from a lot of IBM research article. I mean, this is more than 200 different kind of publications in the context of ethic, to actual open source toolkits that are actually usable and shared by IBM. So that's something IBM donated to the Linux Foundation. And there are like 5 or 6 different toolkits addressing different ethical issues. So, of course, these toolkits are actually some of the concerns are also integral part of the commercial offerings that we have, and you can also find some tooling in Watson Studio or CloudPack for Data in the IBM offering. So, Georges-Henri, I was rather fast to give you more time to present us the toolkit. Can you?
Thank you very much, Xavier, and I will now share my screen. Okay, can you see my screen, Xavier, now?
Yes, not yet. Back to the... Yeah, it's all good.
Okay, excellent. So Xavier has focused on the, philosophical, social, and ethical aspects of AI and ethics, and of course this is the entry point for any further work on this subject. I am going to focus now on the technical aspect with a tool called AI Fairness 360. I will give URLs on the fly. Here you can see a few of them. They're very easy actually to find with your usual search engine if you wish. My sources are from the original AIF 360 website that I will dig a little bit later. And also there is an open data science for all site, which is a good source for learning about AI in general and many aspects of AI, including ethics. So again, we mentioned the principles. I'm not going to come back on that. Autonomy, informed consent, beneficence, non-maleficence. This is, of course, all understood. So as we mentioned before, when we take a decision by a machine, how can we trust this decision? And there are multiple aspects on that. There is the fairness aspect. There is the explainability aspect. There is the question of did any human tamper this decision, and is it accountable? I mean, who should I blame if there is something wrong? I will focus on the fairness aspect. So the fairness aspect is about discrimination either on individual or on groups. Actually, AIF 360, which is, by the way, a Python open source library, is intended to both aspects, except that I will focus more on the group aspect. Okay, so we have to understand first that any kind of machine learning decision at some point is by its nature some sort of statistical discrimination. At least from an individual point of view, there is a system at some point which will tell me, we take this decision for you, let's say, for example, a credit decision, because in similar cases for other people, we are rejecting your application for a credit, for example, because similar people in the past, in similar cases, in similar situations, have failed to be able to refund this loan. And it's somehow unfair because, well, I'm not the other people. My intention is definitely to be able to honor my contract and do things like that. So somehow there is some kind of discrimination. So now there are, from an individual point of view, there is some form of discrimination. So we can discuss many definitions of discrimination, and you'll see that there are, a very big number of definitions. But now, if we are focusing on groups, then it's another question. The question is this group systematically privileged with regard to the decision I take with my artificial intelligence system? And this is the question I will try to focus on right now. So we have to be aware that there have been a lot of algorithm and machine learning algorithm that have made very bad decisions in the past. For example, we have this COMPAS algorithm, which was a United States algorithm meant to evaluate if a criminal would be likely to reoffend. So it's a recidive scoring algorithm. And if we look at the right positive, false positive, right negative, or right positive of those decisions that this algorithm, this precise algorithm took, it's kind of frightening. For example, you have much more white people who were labeled low risk but actually reoffended than non-white people, and same thing for the false negative. So this is very disturbing, and obviously this should not happen. And there are plenty of examples like that with Facebook, with Google, with etc. There is this Amazon example also, where the AI recruiting tool actually had a bias, and it taught itself a bias from the data it had. So a few years ago, up to 2015, say, or 16, the main focus of artificial intelligence was accuracy. Is my model accurate? What should I do to make my models more accurate? And this was basically the only focus. the speed of the algorithm and its accuracy. And of course, many definitions of accuracy here. There are multiple of them. I'm sure that most of you are aware of them. But at some point, there was a turn because of course they were accurate with regard to the training data, with regard to the validation and test data. But those data by themselves were biased. So at some point, there was a turning point, and now we can say that research papers are really focused on fairness and on ethics, etc. So as I said, there are many definitions from fairness. They come from committees of ethics. IBM is participating to many of them. And the purpose, of course, I mean, and anybody who is interested in this domain should kind of participate to this public debate. But when you are at some point, you have to be technical and say, what do I do with those definitions? And the idea is to implement them into algorithms. And of course, when you apply when you are developing a specific application at some point, you can say, okay, this definition here, among the 21 or more, I mean, this is the one that I want when a use case is defined. But here we're talking about a library, and the library is supposed to encompass all the, I mean, state-of-the-art definitions. So there are plenty of definitions depending on the concept. Some definitions conflict each other, so we should be aware of that. So there is a big work, I mean, upfront before the development and what should we use as a definition. We need in the library a comprehensive set of tools, of metrics, and the biasing algorithm to be able to address that. So now let's have a look at the life cycle of a data science or an AI model. So at first there is the data, the input data. Of course, most of the bias in AI come from the data, not the algorithm. I don't think that everyone, all of them, but most of them, they come from the data. So we need data metrics to apply on the training data to say, are those data, I mean, AI is basically about learning on analogy. So learning on past decisions. Are my past decisions fair? So I need a set of tools, a set of metrics for that. Second point is, of course, if they are fair, I can go on and continue my regular processing. But if they are not fair, I need some pre-processing algorithm to kind of debias them and be able to say, okay, my data set, my training data is not fair. The decision I took in the past were not fair, but let's modify them to make sure that the training data will be fair. So what decision should I have been taken in the past? Which is, again, a very open question, if you think of it. Anyway, there are plenty of algorithms for that, pre-processing algorithm. We might not have the privilege to modify those data. So there are a set of algorithms which are called in-processing algorithm, and which modify basically the training algorithms in order to incorporate not only accuracy objectives, but also fairness objectives. So those are in-processing algorithms. And again, we might not have access for a given model to the training algorithm. We might just have a service, which is an AI service, and say, do that system take fair decision? And of course, here I can use my input data set metrics, but I cannot use also post-processing algorithm and metrics, which are classifier metrics, which are, of course, includes the input data metrics, but the output data metrics are can be more than that, because they can not only have access to the decisions, but also to the ground truth. And this way, have metrics based on on the false positive, false negative, well, the confusion matrix, basically. False positive, false negative, true positive, true negative. So AIF 360 is a Python library which includes more than 70 metrics. So think of that. There are 70 metrics. This is the state of the art today. And they are needed because in different use cases, you need different metrics. There are more than 10 mitigation algorithms. Why is this library interesting? Because it's comprehensive. It basically encompasses most of the state-of-the-art metrics and algorithm we have right now. I mean, totally comprehensive would be impossible because, of course, this is an evolving. Each day there is some new thing going on, but AIF 360 is incorporating them on the flights. Some of the metrics and algorithm are only available in AIF 360s, and this is extensible. And extensible first because it's open source, so you can basically copy the source and modify the algorithm as you wish, and create new algorithm if you want in this context. But also in the sense that you can publish them back to the community through GitHub, typically. And we'll see the GitHub address a little later in my presentation. Okay, so the idea is definitely to make a bridge between research and practitioners. And I hope I will convince that this is a success. So how do we measure bias, and where does bias come from? So as I mentioned before, most bias come from the data. So it can come from many reasons, and the most common reason is oversampling and undersampling. So oversampling and undersampling is a very easy to understand concept. I will not dig on that. Basically, it's, I mean, taking more example on a subset on the population than the other, and making it too representative of, I mean, it should not represent the whole population, but it does in the training data, which leads to bias. So there are plenty of bad effects, and the one I took here is a study from MIT of top face recognition services. And by the way, I want to mention that IBM has withdrawn from there is no application of face recognition from IBM. IBM does not wish to be in the face recognition market. But the point is, there are some face recognition services out there, and most of them are biased, typically on race and gender. And here you can see that there is a kind of bias on the accuracy. So this is extremely bad. Okay, so what can we do with this bias problem? And first approach would be the naive approach, which is basically, well, there is a bias on the gender. Okay, let's drop the gender column in the training data. Or in this example here, there is a bias on the zip code because some zip code correspond to places where people are, quote, privileged. So let's remove the zip code column. And this example of this zip code column is a concrete example that has raised in reality. Anyway, this does not work at all because, as you can imagine, many other features and most other features are correlated with the feature you want to drop. So you will have bias on the gender, even if you remove the gender column. You will have bias on the zip code, even if you remove the zip code column from the training data. So what are the basic concepts that you need to understand to use a library like AIF 360s? There is this notion of protected attribute. The first notion of protected attribute is that I want, for example, to make sure that gender, there is no bias on gender, so I have to declare that gender is a protected attribute. So it's a column that separates the population into subpopulation that I have a suspicion there is bias on those subpopulations. And a pre-jailed protected attribute is the value for one decision for this population. For example, I suspect that there is. I am taking decision on hiring people, and I'm suspecting that there is a bias on gender, and I am suspecting that male are privileged. So I can declare male as protected, privileged. What is group fairness? Group fairness, as I mentioned before, is the question about, is there a group which is systematically have advantage on the decision that I take overall, for no other reasons than that. And individual fairness is, does one individual get similar decision with regard to similar situations? And AIF 360 addresses both. And again, in the examples I will give today, I will speak mostly on group fairness. A fairness matrix is a way to measure how much unfair or fair a decision is overall. And a favorable label is, I have to know, of course, when I want to apply my algorithm, what is a favorable decision as opposed to an unfavorable decision. And typically in the credit decision case, giving the credit is the favorable label. This is pretty obvious, but of course you have to give this as input to all those fairness metrics and fairness algorithms. So let's take a few examples on metrics. So in this example here, I am taking metrics both as input data, training data, and metrics for output data. So in this example, I have two groups, and some arbitrarily I have called them unprivileged and privileged, and I say arbitrarily because in this first slide here, we have taken basically the same decisions. I mean, the same number of decisions for each subgroup. There are the same number of positive, negative, same number of false positive, false negative, true positive, true negative, etc. So that's fine. But now let's say that I take one true positive out of the unprivileged and put that in the negative one. So now it's obviously unfair. So how do I measure that? I can measure that with proportions on how many positives, what is the proportion of positives for the unprivileged subpopulation, and what is the percentage of positive for the privileged population. So here it's 60 for the unprivileged and 70 for the privileged, and the difference is 10, and this is called the statistical parity difference. Okay. Instead of making a difference, I can make a ratio, and this is called the disparate impact. Okay, and of course, I can now take example of output metrics, taking into account false positive, false negative, etc. Here, I can take I can measure the proportion among among the real positive, the ground truth. How many positive did I capture? So in the unprivileged case here, I captured 71% of the true positives. And for the privileged one, I captured more, so it's unfair. And the difference is called the equal opportunity difference. And this is about true positive. If I do the same thing about true negative, I can also calculate proportion and calculate the difference, and have the false positive odds difference and the true positive odds difference, and I can have the average odds difference, which is the average of both. So as you see already, we have 5 or 6 definitions very quickly, and actually there are, as I mentioned before, more than 70. Okay, so in reality, how does this happen? How can we think about applying a fairness metrics? What fairness metric do we apply? We have to think that depending on the fairness metric we do apply, we will find different results. So, for example, the SAT is a very common college exam in the United States. For entrance in college and university. And is it fair or unfair? Well, it's fair in the sense that, yes, it correlates pretty well with future success, and it correctly compares the actual abilities of applicants. So it's a good metrics. SAT itself is a good metrics and is fair from the point of view of it does the job somehow. And the metrics which would measure that would be average odds difference and average odds difference. But no, now if you compare different subgroups like non-English versus English-speaking parents, single parents, low income, blah, 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 no, they are not, SAT is not fair. So this is a very intuitive example of, I mean, you will get different results depending on the metrics that you use, actually. So let's come back now to this life cycle for data science / AI models, and we mentioned all the algorithms and metrics that we can put on this diagram. So we mentioned the metrics. Now let's have a look a little closer to the algorithms. So we have, as mentioned before, pre-processing algorithm, which basically take a biased training data into unbiased training data. We have the in-processing algorithm, again, which kind of gets into a regular machine learning algorithm like linear regression, like random trees, like neural nets, etc. And they kind of mitigate the results on the fly to converge to something which is as unbiased as might be. And we have those post-processing algorithms which take the output and maybe use those metrics as indicators to what direction we should change the results. Okay, so this is a set. This is the list. Well, the actual list right now of the algorithm that you have in AIF 360. I'm not going to, dig in all of them, but let me describe just two of them. So reweighting is about a pre-processing algorithm. It's interesting to mention this one because it's pretty close to what anybody would do intuitively. So we have a biased data set. How can we make this biased data set unbiased? So we can intuitively think that, okay, if there are too many good decisions, for example, for male against a female, I should remove some female good results. So I should basically have less good results for male. And on the contrary, so I should reduce male good results, and I should augment female good results, favorable results, outcomes, decisions, should I say. And actually, there is a good way to do that, which is not augmenting by duplicating the decision, but putting a weight on those decisions. And some algorithms are able to use this weight and in order to say, okay, this individual counts twice or 1.5 more than this other one, because we know that this will lead to an overall better and unbiased, fair decision. Let's now move to in-processing algorithm. So I'm going to focus on the prejudice remover. So prejudice remover adds a discrimination-aware regularization to the learning objectives. So what does this mean concretely? It means that there is not only this objective of accuracy right now in the algorithm, but also there is this objective of fairness. And we are trying to mitigate them on the fly. Okay, IAF 360 includes many of those algorithms. I don't think that this list that I gave right now is totally exhaustive, and there are much more in IAF 360, and we'll see how many we have a little later. It comes from of course, IBM research, but only from most of the good players, I mean the top players in AI. Okay, I'm not going to put emphasis too much on this one. Of course, the idea here is to do the processing as early as you can in the life cycle. For example, reweighting, I mean, it does not change the labels. It changes the weights. It adds a weight column, so it gives some kind of transparency. It's not like totally changing the data, which is interesting. And this is not the case of other algorithms. So, of course, how can we trade off bias versus accuracy? And of course, they are opposite somehow. They're conflicting objectives. Basically, when you want to have maximum accuracy, the bias will get higher somehow. And of course, how do we trade off? And they might be constraints, typically legal constraints, ethical objective, and of course the point of all that is to move to something which gives the customers and the users trust. So what should you do if you are a data scientist or developer and you want to add debiasing in your application, which takes data science model into account and into the picture of your overall application? First, you should take stakeholders very early in the process, because they will help you define the metrics and the real objectives of the debiasing. And typically, they will tell you what they suspect as privileged and unprivileged populations. Of course, once you know that, try to apply the algorithms as early as possible in the life cycle, which is basically in the pipeline, in the AI pipeline. And then the third point, which is very important, is assess this very often, meaning be able to monitor in details what is drifting. So all those applications, they are meant to be put into, all those libraries, and specifically IAF 360, they are meant to be incorporated into applications. And as IBM, we have developed applications too, and we have developed a suite for developing models. And of course, we have incorporated those applications, AIF 360s in those applications. So our suite, which is called Watson, includes a module to do preparation. It's called Watson Knowledge Catalog. We have a model called Watson Studio, which is meant to build models. We have a module called Watson Machine Learning, which is basically the deployment environment. And of course, we have a monitoring managed module, which is Watson OpenScale. And in Watson OpenScale, we have incorporated multiple libraries that I mentioned before, including AIF 360s. And of course, those are the features of Watson OpenScale. I'm not going to go into the details of all those features, but please be aware that there is this mitigation feature for biased model behavior. So there is this fairness feature, and this explainability feature also, by the way, using, by the way, another library called AIX, X for explanation, AIX 360. So this is how it looks, basically, when you don't use the code, but when you expose the code as, in a GUI, while you expose those metrics and you expose those attributes in such panels here that you can see. So I'm gonna now move to a very quick demonstration. First, I want to mention that we have a very interesting URL, a website, which is called AI Ethics from IBM, and which points out all the principles that we mentioned before, the 3 principles of ethics in AI, and the 5 pillars, including explainability, fairness, robustness, transparency, privacy. And each of them comes with, tools. Those tools can be libraries or of methods. So fairness is typically 360s. So if you click on this one, you access the AIR 360 website, and it's a panel which introduces AIR 360s. You can, from there, read more about this library. You can go through a web demo. I will go through this demo. You can watch videos, read the original papers, because of course we make the explicit relation between the metrics, the algorithms, and the research papers, which are at the origin of those metrics and algorithms. There are tutorials. You can join a Slack to ask questions and participate. There are example notebooks, and of course you can contribute by going to the GitHub. So first we can click on this Python API doc, which gives you how does this library looks like. Well, as I said before, there are of course metrics here, algorithms, and data sets, which is good because it allows you to train on those and do tutorials on this library with the embedded data sets and start from there. And as mentioned before, there are subclasses for pre-processing, in-processing, and post-processing algorithms. And there is also an explainer meta class, which basically is about being able to produce text about a metric. And this is important because it's a kind of standard. You can expose a metric to your GUI, and you produce this text automatically through those quote explainers. All right, so we can dig here, for example, into the metrics and see that there are binary metric, there are classification metrics, etc., etc. We can dig also into the algorithms. So let's take the example I took before about the rerating algorithm. The rerating algorithm, of course, there is a pointer to the original paper, research paper. There are the methods, which are fit, predict, fit transform, and this is very similar to what you have in scikit-learn. So, data scientists who are used of standard libraries, machine learning libraries. I'm thinking of scikit-learn or SparkML, for example. They will find this library very easy to use. Okay, so let's move to the online demo that you can by yourself do if you go to this AIF360s.mybluemix.net website. You first choose your data set. So I'm going to take the Compass data set that I mentioned before. There are other data sets, the German credit scoring data set, which is about, deciding if you accept the credit request from a customer in a bank, for example. And there is a third one, which is also pretty common in in the literature, or I mean, in the research literature for ethics and fairness. So let's dig on Compass. So in Compass, what are the protected attributes? So Compass, again, is about the decision about how much do we think that some convicted person will do recidivism. So it's a recidivism prediction algorithm, likelihood of reoffending, basically. So the protected attributes are sex and race. In sex, privilege are female and privilege are male. And for race, privilege are Caucasian and unprivileged are not Caucasian. Okay, and there is this learn more button that leads you to another more detailed explanation about this use case, which is a real one. So the next point, of course, is to check for metrics. So here the metrics. So we have applied. Yes, we are applying the metrics on the input data set. And we see that out of 5 metrics here, the statistical disparity difference, equal opportunity difference, average odds difference, disparate impact difference, the one that I have mentioned before. And there is also the Thale index. The Thale index is more individual fairness index. And I will not dig too much on that. And by the way, it's okay for this particular example. So out of the 5 fairness metrics, well, they are all in the red color, and they are all indicate. I mean, the 4 out of 5 are indicating bias. And same thing basically about race. And this might be different. Some we want them close to 0, and for example, disparate impact, which is a ratio, we want it close to 1. Okay, so the next point now in the demonstration is to mitigate them. So I can use algorithm that I have mentioned before. So let's apply reweighting and see how much this corrects the biases that we have measured before. So we are training, comparing the original versus mitigated results after. Before mitigation and after mitigation. So we have original and mitigated in red here. And in the first case, out of the 5 metrics, they all are now totally mitigated. They are in a acceptable range for the metric. So acceptable again needs to be defined, and here we took the by default values. And of course, acceptable depends on the use cases. So this is a very open question again. Same thing for protected attribute race. But this might not be always the case, depending on the algorithm that I use. So here, rewriting, I use an algorithm, a debiasing algorithm, very early in the. I am almost done, by the way. In my demonstration, there is this rewriting algorithm, but I can use it later in the process, and you will see that the result might be a little different depending on the algorithm I use. So we go here again, it's an in-processing algorithm that we use, and the in-processing is not able to basically get the bias to an acceptable interval. It reduces the bias in most of the cases. For the race, it works, but for sex, it does not. And of course, this is something you have to test when you are developing. And finally, you have to be aware that we have this GitHub, github.com/trusted-ai/AIR360. You can basically reach also this GitHub by here, say get Python code here, and it will send you directly to this GitHub. It's important to know that, because it's where you can participate to this project. to this open source project. And I will finish very quickly to show that there are also plenty of examples, and here we have examples and Vue notebooks here. So there are plenty of notebooks in the GitHub, and I have given this example here that you can dig, where you see what libraries you should import, what bias is in red here, looks like before applying the mitigation. And so first, in the case of logistic regression, then random forest model. And this is bad, by the way. Here you can see that we are not close to 0 at all. And we can see that after mitigation, after reweighting, typically here, logistic regression after reweighting, it gets much better. And it's a good way. Those examples are very good ways to learn how to use concretely the library. And I will stop here.
Okay, Georges-Henri, thank you. We have some questions, so maybe some are related to the subjects that you just covered. So I will start with the first one, and I will read it because we are streaming to a lot of different platforms. So the first one is: ethical AI seems hard to measure objectively. Many terms like explainability are not strictly defined. What is an explanation? There seems to be no consensus, and is there some effort to fix this?
Yeah, today I have more focused on fairness than explainability, but in explainability it's basically the same idea. There are plenty of definitions, and it would take another hour or 2 hours to go on this explainability terrain. But it's basically the same thing. Yes, in explainability you have multiple definitions. There are committees which discuss and research groups which discuss on what should be explainability. And the answer to your and again the libraries are quite exhaustive. If we take AIX 360, the idea is to take most of what is on the state-of-the-art market, if you want, to implement it, and after let the choice to stakeholders, data scientists, and developers. And of course, this is not an answer. The answer is there are plenty of them. We have put all of them in the library. So where do actually address the question, what should we use? Well, we actually address the question, what definition of explainability we should use, what definition of fairness we should use. Well, this is really at the level of the project. Each project, each application requires stakeholders users and all stakeholders to discuss what definition, what metrics, what algorithm, what etc. that they should use. This is a real case by case answer. There is no kind of general, magic way to do that. And of course, the danger is okay. We want a fair application, a fair decision application. So we have a project. So let's take the metrics that is the best for us. And of course, this is totally a bias. Decide in advance. Decide afterwards what metrics you use. We take the metrics that is more efficient, that shows fairness. This is extremely bad. Of course, it has to be decided in advance. So I don't know if I totally answered that. I don't know. I can totally answer that, but
yeah, this is still an open question, because explainability is still a research subject. The tooling has to be improved. These toolkits that IBM released are, let's say, a first step, and we encourage a lot of people to work on them and improve them. But of course, this is only the beginning. So explainability is a hot topic. You want to be able to explain and maybe also find what are the best, the most influential parameters that led to a specific decision. There's some work also in the area of causality. Networks should be able to explain, but they came to a specific decision. So that should be part of the AI itself. So this is still a work in progress and very, very active research area. Another question was, if you detect bias in data, is there a legal obligation to report that to the owner of the data so that they can alter their actions outside of the algorithms? Example, in their day-to-day operation. So yeah, I'm not aware of any legal obligation that would be that would mandate anyone to report these kind of issues. In the past, I mean, a lot of citizens have detected some bias in some data sets or in some algorithms and try to speak out loud about the issues. So it happened in different areas like justice in the US, like facial recognition. So yeah, citizen needs to be part of the let's say the warning. Yeah.
Correct. Fairness is a little more fuzzy than explainability, by the way, because for explainability, there are, for example, legal constraints in GDPR or GPD, which is the European law for privacy. It's about decision should be transparent and then should be explainable. So somehow there is a legal aspect for explainability. There are plenty of I mean, GDPR is a, or GPD in English is a very common example of legal enforcement of explainability. For fairness, I don't know any examples, but I think there might be some examples. But they are not as, you know, it's not as easy as to pinpoint them into a text, into a legal text than explainability.
And the last related question is AI inevitably biased, made by humans for humans? So I don't think IBM is thinking about, let's say, totally avoiding bias in anything. I don't think it's even possible. Society is biased, data is biased. I mean, but data could be flawed because it does not involve enough case of different races or different skin colors or this, you know, I don't know. So it could be a flaw in the data, but it could also be perfectly matching the reality data set, but that would actually be reflecting the bias that are actually in the society itself. So what we can do is really try to identify all the biases and try to mitigate them. So it could be, it's really also at some point some political decisions, I mean, to enforce fairness and equity in our societies. So yes, I think they are inevitably biased, but we have the right tools and probably the opportunity to identify them and to fight them.
Correct, and again, the source of bias, if you think of it in AI and typically in neural networks and machine learning, it's about learning about past decisions, and typically human past decisions, and most of them are biased. So I mean, it's crucial to address that. It's crucial to address that.
Great, guys. Thank you very much for this session. It was very, very interesting. And also, thank you for answering the questions. We have still one more session. It won't be in the same link. We will send the link in the chat. But of course, don't miss tomorrow. We have the third day of the festival. So the link will be also already in the chat so you can see it. And the topic is about cloud. We'll get some hands-on on open source enterprise technologies like serverless, OpenShift, Kubernetes. So join us, please. Javier, Georges, Henry, thank you very, very much for your time.
My pleasure.
See you too tomorrow. Maybe join us and watch the other session. So
absolutely.
Will do.
And as I said, thank you very much, guys. So as I said, our final session today is starting right soon, like 4 p.m. CEST. Is a series about data, AI, and automation from our colleagues in Germany, Austria, and Switzerland. There are over 8 sessions, which Felix and the team will show you how automation, like you've never been seen before, in AI lifecycle, in document processing, document classification, in cloud native application, and even robotic processes automation. All 8 parts are free and online, so join us and the team in Kratos. You can see the link in the chat. So thank you very much. And of course, stay in touch. We have a great CrowdCast community. And if you want to follow us and see when we go live, so you can click on the button on the top, which calls IBM Developer Europe, or we'll just post it in the chat as well, so you will see it in the chat and you can follow us. And thanks again for everyone for joining us. Looking forward to seeing you all tomorrow. Another day of live sessions. Start soon. Thank you. Thank you very much.
Thank you.
Thanks, everyone. Bye.
Bye-bye. Thank you.
Bye-bye. Thank you.